यार ये हमसे हिलेगा तो आई थिंक वहां तो नहीं वर्क होगा हैदर. Go ahead. So, shall I start now? है ना? यार थोड़ा सा मुझे माइक चाहिए. Ladies and gentlemen, a very good morning to you all. I am Reema.
And I'm Heather.
And we both take immense pleasure in extending our warm welcome to all our esteemed panelists and respected participants to this symposium, dedicated to Mr. Mahendra Raj on his 98th birth anniversary, honoring a legacy in structural engineering and architecture in India.
The symposium celebrates the life and contribution of late Mahendra Raj, a colossus who straddled 6 decades in the building profession, who designed many beautiful large span structures, some one of their kind globally, demonstrating a mastery in the art and engineering rarely seen.
Let's start this auspicious day by lighting the lamp. May I please request Ms. Tanuja Kanvinde, Mr. Sanjay Kanvinde, Mr. Balbir Arora, Professor Prem Krishna to please do the honors. To begin the program, I now invite Mr. Manoj Mittal, President of IS Structi, to please deliver a welcome address. Mr. Mittal is a second-term president of Indian Association of Structural Engineers. He is an accomplished civil and structural engineering consultant with over 35 years of professional experience. A graduate from BITS Pilani, Mr. Mittal is a member of several important BIS committees. He is also affiliated with School of Planning and Architecture, New Delhi, as visiting faculty and has served on the board of Power Grid as an independent director. He is also hosting a podcast called Samvad.
Good morning, everyone. Today is 98th birthday of Mr. Mahendra Raj, who left us on 8th of May this year. All of us know him as a legendary structural engineer, great human being, and an inspirational mentor. Each of his work is a piece of art. His work enthuses structural engineers and architects alike. We might be missing him in person, but he will always be with us through his works and rich legacy of creativity and excellence left behind. On behalf of Indian Association of Structural Engineers and Studio Venro, I extend my heartiest welcome to all participants, speakers, and panelists in this symposium. Around 400 participants and 2 panelists will be joining online through Zoom. I also welcome them to the event and hope they will have equally enriching and enjoyable experience as others. I am happy to note that today we have perfect mix of civil and structural engineers, architects, academicians, journalists, historians, and students. It is rare to see such a gathering in any event. This symposium was conceived in one of the meetings of the publication committee of ISTECT. In fact, publication committee wanted to bring out a special publication on the works and life of Mr. Raj, coupled with incidents and stories narrated by his collaborators and team members. Mr. Rohit Raj and Ms. Vandani Mehta were also invited to that meeting to take up this work. It was thought that such a symposium on his birthday will be a good starting point for it. I'm extremely happy that all the sessions have been planned to bring out various facets of Mr. Mahendra Raj. I'm sure all the participants, particularly the younger ones, will learn a lot from it. As you know, Mr. Mahendra Raj was instrumental in setting up of ISTECT, and he led this association till 2010 as its president. This association was very near to his heart. He contributed in it till his last days. Association has become a national apex body of structural engineers and is known for its quality technical programs and publications. In view of contribution of Mr. Mahendra Raj to the structural engineering profession in India and his affection to the ISTECT, and to carry forward his legacy, Governing Council of the association had decided to celebrate 11th November, his birthday, as Structural Engineers Day every year throughout India. So today we are celebrating our first Structural Engineers Day. I extend my greetings and good wishes to all of you on this day. We are requesting other professional associations and bodies for the same. I am hopeful that it will be widely appreciated and will become an important annual event in the years to come. I hope you will find today's deliberations interesting and useful. I once again welcome you all. Thank you.
Thank you, Mr. Mittal, for your message and for marking this day as a Structural Engineering Day in honor of our beloved Sir Mahendra Raj. I now invite Vandani Mehta and Rohit Raj Mehdidatta to share a presentation on some of the inspiring and innovative structures from the monograph, The Structured Works of Mahendra Raj. Rohit Raj Mehdidatta, MD, MRC Private Limited, and co-founder, SVR Foundation, is a practicing architect, artist, and an urbanist. He manages a disciplinary practice with Vandani Mehta in New Delhi. Their architectural and research work has been widely presented, published, and exhibited. Rohit has been in expert panels and committees on public arts and urban development initiatives. Vandini Mehta is an architect and urban researcher. Along with professional practice as a co-founder of SVR Foundation, she has been visiting faculty at School of Planning and Architecture, Delhi, and several other architectural and urban design departments. Vandini and Rohit, along with Adil Hubbard, co-edited the monograph titled The Structured Works of Mahendra Raj that has been presented in several cities globally, and with Rubina Karode curated an exhibition at Kiran Nadar Museum called Structuring Form, the Innovative Rigor of Mahendra Raj.
Good morning. Uh, Thank you, Mr. Mittal, for this beautiful welcome address. And on a special day on my father's birthday, this is a memorable way to start his journey post his life here. That November 11th is celebrated by engineers across the country as Structural Engineers Day. I think he'll be smiling from there, blessing all of you. Not for him, but for the fact that engineers are being celebrated. Today's presentation, we have called it a structural narrative of Indian modernity because the oeuvre of Mahendra Raj inflects and contributes and helped create many artifacts that pioneer the narrative of Indian architectural modernism post-independence. In this presentation, we will discuss only a few of his works from over 250 projects to choose from over the last 6 decades. Each project that we have chosen shows a visionary and pioneering engineering solution, exemplifying the bold and adventurous innovations his practice engaged in. As we discuss these works, the underlying story that emerges is of a transnational exposure and exchange of brilliant architectural and engineering minds. Le Corbusier and Khan experimenting in India, Indian architects, Doshi, Correa, Rajwal, Kanvinde, sort of traveling west and coming back to engage with each other, and local systems of construction, of navigating the Indian ecosystem, we feel created a fertile environment, an incubator of ideas that defined Indian modernism. Because I can't change the slide. Raj's interest in structure started in 1951 when he was appointed as assistant design engineer for the construction of the Chandigarh High Court. The geometric parasol roof, consisting of shells, presented the engineers with both structural and functional hurdles. Working with other engineers, he, with his senior Gulzar Singh, proposed modifications, that of a balanced cantilever roof supported on 2 columns, which made the construction possible. Working in 1953 in Chandigarh, he continued to complete the responsibilities of finishing the High Court and then designing the Secretariat as an executive engineer. Seemingly a simple frame structure, the Secretariat was an exercise in an extremely detailed articulation of the building's facade. Raj took the bold step of presenting alternatives to Le Corbusier to circumvent some of the problems the original facade in the design presented. Although, I mean, this is the image what Corbusier on your left presented and what Raj proposed on the right. Although somewhat resistant to the idea of adapting his designs at first to an Indian engineer, once he had examined Raj's proposal, Corbusier accepted them. In the absence of structural design education in India, he decided to go to America for further studies and subsequently moved to New York City to work for Aman and Whitney. Because of his Chandigarh experience, Mr. Raj worked in the special structural division, an international space of eager young minds that was instrumental in shaping his attitude towards structural design as an art form. Abba Tor, a colleague and close friend from Aman and Whitney, states, Boyd Anderson, Andy to us, was the partner. Okay. Boyd Anderson, Andy to us, was the partner in charge of the special structural division. He was an inspired and inspiring engineer. He made us look at structure as a breathing, living, dynamic, moving, and somewhat even mischievous creature. We all got rid of the notion of statics or make it stand up. Our real job was to tame the structure, allow it to move within limits without affecting its serviceability in the process. It was in this nurturing and challenging environment that Raj blossomed, where all his peers as well as superiors in the firm appreciated his engineering sense and people skill. Raj worked on the Mohawk hanger, a 150 balance cantilever in folded plates, as a design engineer. His next project was a 400-meter diameter concrete folded plate dome, 10 centimeters thick, resting on a circumferential concrete ring for the assembly hall in the University of Illinois. His intuitive structural sensibilities contributed to significant design with respect to the manner the folds were configured. During this period, he also honed his ability to work with unconventional forms in the sculptural framing of the US Embassy building in Dublin. Eventually, in the early 1960s, he started his practice in Bombay. The 1960s were exciting times for the newly independent nation. This decade was energized by the emergence of a new generation of professionals in every field eager to make their mark. This was also an important juncture for Raj as he developed a practice that broke new grounds in the field of architecture and engineering. The manner Raj constantly stuck his neck out, as Korea often mentioned, empowered leading architects of the country to create structurally expressive forms through all his decades of practice, despite technological and material limitations. Many of his works belong to a time where inventive use of concrete as a building material was popular the world over. In countries such as India, lower level of mechanization and cheaper construction and labor allowed unique experimentation that Raj exploited to create artifacts that are uniquely indigenous, but also remarkably global in nature. The result, as Mark Jazenbeek states, is his astonishing contribution to the history of architecture of India that has really no parallel anywhere in the world. At the risk of simplification, we would like to discuss, Vandi and I, today his work in two categories. First, the structural expressive buildings, many of which were large span and first of their kind in the world, which I will discuss right now. And then Vandini will come to talk about innovations in structural elements that allowed new spatial possibilities. Raj's first project in India with Charles Correa was the Hindustan Lever Pavilion, a temporary structure designed for the 1961 Industrial Fair in Delhi. It was inspired by crumpled paper. Raj suggested that every crumple have a definite geometric shape, such as a triangle or a quadrangle. Interestingly, other than the architectural plan and approximate sections, there were no drawings. The structure was analyzed, designed, and detailed on the basis of a scale model alone. Raj's structural drawings that specified plates varying from 2.5 inches to 8 inches, along with a scale model, became the dimensional base for the construction on site. And this is why I think even the contractors of this period were heroes. They managed a lot. The notes on the drawings guided the contractor on the method of building in constant reference to the model, as inclinations of the plates could not be established until after the formwork for the whole shell was erected. The concrete in the foundation could only be poured along with the shell. The next two outstanding projects in folded plate, both in Ahmedabad. The first with Charles Correa was the cricket stadium for the Ahmedabad Municipal Corporation, completed in 1965. Mr. Arun Menon here will tell us in greater detail about this. What is noteworthy is the delicacy and the elegance that the structure attains as thin folded plate systems rise from the ground and forms an integral whole with the spectator stand and a 20-meter long cantilever roof. Each part of the structure works with the other in a fine balance. This structure, folded plate as cantilever, was the first of its kind at that time. The 20-meter cantilevered roof has a tapering fold anchored to the folded inclined leg that in turn combines to the seating frame. Both the inclined leg and the seating frame rest on a tendon-like combined strip footing. The elegance of the foundation form is because of the way the incline allows the center of gravity of the super loads to pass through the combined strip footing. This way, the large cantilever moment on the frame is dissipated by the time it reaches the foundation. The inclined legs of the main frame and the seating frame were cast first, and the cantilever roof were cast later in segments. After completing the entire sector, the variations in the deflection at the tips were equalized by either jacking up or weighing down different folds and then casting the front diaphragm connecting all the folds. The notes carried all these instructions. The second project with B.V. Doshi is the Tagore Memorial Hall. This performance space takes Raj's explorations of folded plate structures further in the form of a continuous wall and roof system for the entire building. An independent understructure of twisted columns designed to follow the lines of stress forms a large cantilever within the foyer space. The elegance and simultaneous structural efficiency emerges from carefully proportioned trapezoidal folds, whose angles and plates thicknesses vary according to the stresses, moments, and forces of the structure. Hence, the depth of the vertical folds is equal to the horizontal folds when they meet each other on the roof and reduces as it comes down. Typical, as we'll hear other engineers speak, Mr. Raj suggested more than 12 folded plate systems to arrive before he finally arrived at the optimum geometry. The clear construction notes specifying pouring sequence and supports and ties that need to be provided for stability for individual folds at every stage of concreting till the rigid frame structure comes together were also provided. This was the labor at that time. Mahendra Raj moved his practice to Delhi in 1970, where he built the Hall of Nations in 1972 with Rajwal, a remarkable single exhibition space of 84 meters by 84 meters covered with a unique space frame structure. Normally, these structures are made in steel. I'll show you which he did explore. But since it was scarce and very expensive, Raj designed it in reinforced concrete instead. I mean, he first designed it in steel, then in precast, and then finally in cast in situ. This translation is characteristic of an open-minded creativity that he coupled with a carefully guided construction practice that were vital given the complexity of the reinforcement at the joints of the space frame. This delicate first ever cast in situ large span space frame is a gossamer truncated pyramid. Our favorite part of this project, which we believe is the secret of its delicate appearance, is what we call the robust rhombus on the right side, on your right side that you see the section. This was a winning section over a circle, a triangle, and many other explored. It measured a mere 25 centimeter on each side. This section helped ease the busy joint of 9 to 11 members, some in tension, some in compression, coming together with a minimum of 36 rebars passing through each node. Raj also carefully conceptualized the stages of construction to help reduce cost and effort. As the entire structure was not supported with scaffolding till the roof, based on extensive analysis, a detailed construction sequence was established. A system of scaffolding would support the structure till level 5, one level above the openings. After level 5, the structure itself supported additional construction, freeing the ground space. Each level gave rise to a new structure that was envisaged and analyzed for the purpose of loading conditions even before the building was started with respect to construction. Also, in this remarkable decade, Raj designed the Hindon River Mills in 1973 with Kanvinde, a structure formed by a series of elegant cast in situ twin arches that span 48 meters and are placed at 15 meter centers. A cast in situ hollow post tension girder, 3.5 meters by 1.5 meters, carrying humidified air, is suspended from the twin arches. Alongside in situ construction, precast double T-section slabs elements were cast on ground and lifted in place with a gantry crane that moved between the arch frames. Lateral stability of the building is provided by interconnecting the twin columns supporting the twin arches with folded plate gutters running through the length of the building. The textile mills typically require enormous quantities of humidified air in column-free spaces of minimum possible enclosed volume to economize on the cost of air handling units. Again, 7 alternative structural schemes were made for the initial flow diagram and layout, which required a 21-meter by 18-meter bay, 2 of them. Subsequently, the client envisaged and enlarged the requirement to 2 sheds of 49-meter by 223 meters each. At this stage, Raj conceived of a totally new structure with twin tight arch systems spanning 49 meters, for which he created a comparison to show that the twin system was more efficient resolution structural behavior and more economical despite higher quantity of steel and scaffolding. So this is what he showed to the client as analysis. Some of the drawings. Finally, in the 80s, also showcased one of Raj's greatest work, again with Convinder sir, the sports stadium in Srinagar, built in 1982, with a maximum cross length of 74 meters. The indoor sports stadium was originally designed by the architects as a cross plan with central pylons to help span the roofs. Raj suggested eliminating the pylons and instead proposed a structural system that radically altered the aesthetic quality of the building, while still adhering to the original intent and basic cross plan. Reminiscent at first glance of the Hall of Nations, the stadium is based on an entirely different structural concept. Both have triangular grids, but where the hall uses a double-layered concrete space frame cast in situ, the stadium uses a single-layered triangulated plate which taper outwards from the cross base to form a continuous ridge on which rests the seating system. The building is divided into 4 identical units. There are 7 typical plates in each unit and 28 plates in the entire structure that geometrically balance each other. And this drawing details one such unit. The normal view that you see on the right side is used to visualize and detail each plate and its nodes in pure geometric form. Post-tensioning was a major tool to contain high tensile forces in some of the members. 4 diagonal members forming a dramatic incline hold the post-tension cables running through the inclined planes. The roof is supported by a post-tensioned edge member that is also supported by these diagonals that you see on the 2 sides of the photograph. To integrate the horizontals of respective plates at various levels, organic shaped joints emerge to manage the geometric resolution and the endings of the post-tension cables. The drawing also proposed the 4 units of the cross plan can be constructed independently till level 5 and detailed out 2 alternatives of roof erection to address possible technological and economic constraints during the construction. And this is how the whole construction happened. I would like now to invite Vandni Mehta to give further insights on Raj's practice. Thank you.
You have provision of a short stool that I can stand on. I'm happy for that. Thank you so much. Good morning, everyone. I'll continue by showing buildings by Mahendra Raj, which were not so overtly about structural expressionism, but instead subtle yet bold innovations through inventive structural solutions that help realize and even enhance the imaginations of several architects. In these buildings, the design of the structural systems and elements, as also of the processes and techniques of construction, give new dimensions and spans of spatial possibilities. Whether it be through cleaning up dozens of columns and creating clear open spans, or lifting off spaces by transferring loads elsewhere. Going back to one of his first projects in the early 60s, this is the new Great Insurance Building. It's a 6-story office block that was constructed in a 3-story garage located in front of Churchgate Station in Bombay. Here, the client and architect wanted to carry the new structure on the existing columns without knowing their strength. Oh, am I going to? Yeah. Instead, Raj suggested puncturing through the existing slabs and making a few additional columns that fork out to carry the columns along the periphery and corridor of the office floors above. A completely different and more plastic design sense can be seen in the Sriram Center that he did with architect Shivnath Prasad for art and culture in New Delhi. Here, the building is resolved through 2 distinct structural systems: a cast in situ drum-shaped auditorium and a 31 meter by 31 meter parasol roof supported on 4 cross-shaped columns. The final product that we see is quite different from the designs originally brought by the architect. For instance, the floating effect of the building now, which is its notable feature, was introduced by the structural changes suggested by Mahendra Raj. Built in 1969, also with architect Shivnath Prasad, the Akbar Hotel's main hotel block required a closed space column and beam framing configuration that the architect wished to carry into the public spaces on the ground level. On Raj's suggestions, however, these areas were reconceived as large column-free spaces, achieved by introducing a transfer girder in the transitional floors above, in the transitional floor just above the lobby. The resultant large span column-free lobby, now commonplace in most hotels, created a new spatial possibility completely. So this is the lobby that was first imagined with columns going through it. But then he opened up, he said, we're not going to have columns here. And this was the resultant. The major load of the 9 floors of the rooms above was now taken by the transitional floor. Craftily, so this is that, again, details of that transfer girder. Craftily webbed, slender ribs allowed a large span to then be handled with minimum rib depth. So these were the ribs that were created at the lobby. And each one of them is varying in depth and thickness. This is the column that comes out of the building. And so those webbed ribs come and join these columns in this with the details of the reinforcement at the column and web. The Central Bank, built the same year, is a 6-storied rectangular office tower emerging from a 4-story irregular shaped podium. This was done with architect B.V. Doshi. Deep box transfer girders here lift and separate the tower from the podium, opening up a large unobstructed public plaza and entry with a delicately suspended mezzanine floor. The tower stands on 4 corner column bays with 2 transfer girders. These carry floating mullion-like columns and slender ribs supporting clear floors 18 meters wide and 36 meters long. Shallow transfer girders carry a system of sunbreaker fins around the tower block on all 6 stories, bringing a bold modernist presence in the old city of Ahmedabad. Premabai Hall, also done with B.V. Doshi, is also in the old city of Ahmedabad, is defined by 2 exposed concrete shear walls with cantilevered ends that extend onto the street, as if a flattened dinosaur form. The roof of the main 55 meter by 37 meter hall, with a seating capacity of 1,000, is supported on 4 shaft columns connected with deep reinforced concrete girders. The seating bowl, supported on 21 meters span, deep wall-like girders, you see that on the edge in the photograph, clears the immense space underneath all the originally proposed columns. The result, a dramatic and volumetrically complex foyer enriched by a structure of deep girders and wafer-thin ribs. Raj also played the role of the structural advisor in another building in Ahmedabad by Louis Kahn, Indian Institute of Management. Kahn envisioned the entire IIM campus in brick with the use of arches for spanning large openings. Here, Mahendra Raj's inspired suggestion of using concrete ties to restrain the arches and take care of the outward thrust enlarged the design vocabulary significantly in this campus of the Indian Institute of Management. The 80s saw further innovation. Raj designed a form that tapers from the ground up for the NCDC office with architect Kuldeep Singh. Someone has likened this building to the Fata Pajama. The structural resolution for shifting load transfers was resolved by the very slim meandering shear walls at the outer edges of the building and parallel zigzagging columns in the center. These columns carry the box girders that tie the two inclined office wings across the building and also form the central connecting corridor that this man is standing in the photograph. So those are the corridors are structural. The form created by these columns generates high tensile and compressive forces on alternate floors, respectively. The connecting corridor is either a tie or a strut holding together and is strengthened by post-tensioned cables on the alternate tensile floors built into the sequence of construction. So this is a drawing for the sequence of construction where you can see how, as the stages of construction move forward, the tensile cables are put into place and, I guess, tightened with the progress of construction. The earlier bare brutalist aesthetics had made the structure visible in all its glory. Now, as we progress more into the 80s, architects, and in this case, Charles Correa, used claddings and finishes to enrich the aesthetics, and the structure was no longer as visible. However, Mr. Raj still continued his zestful explorations of structural clarity. The Vidhan Bhavan in Bhopal, built on the undulating terrain of central India, its circular form represents the architect's move towards prioritizing materials and narratives over structural expression. Still, this building's main programmatic spaces, with its bold structural forms that create a roofscape of domes, shells, and a tower, bear Raj's stamp. A doubly curved shell roof for the multi-purpose hall is set on a triangular base of 43 by 43 by 36 meters, and the main Vidhan Sabha hall, a 31-meter diameter hemispherical dome in concrete with a thickness varying from 10 to 20 centimeters. And the Vidhan Parishad has a composite space structure in concrete and steel covered by a 14 by 40 meter roof. Two main lobby areas have impressive large span spaces of 30 by 30 meters, each supported by only 4 columns. Mahendra Raj's oeuvre reveals the technologies of construction in different decades emerging and innovating within and beyond the dictates of the architectural styles. Each project that we've chosen shows a visionary and pioneering engineering solution where the structure makes a bold statement and is integral to the architectural expression. This is a quotation from one of the architect engineers that inspired Mr. Raj as well. And I stole it from one of Mr. Raj's presentations because I thought it really so aptly describes his own work. And it says, the pattern of steel sorry. The pattern of steel should always have an aesthetic quality and give the impression of being a nervous system capable of bringing life to a dead mass of concrete. And you really feel it in his buildings, but more so when you look at his drawings, you really can feel that, the nervous system, the X-ray almost of the nervous system. This body of work marks a significant era as it showcases the nuances of engineering design and explorations of concrete as a new material to its possible limits, but also defying technological and material limitations within the country at that time. Almost all these projects shown in the era of what we could now call modern heritage have invented and evolved analysis and design procedures with limited or no access to computers. I want to sum up this presentation by highlighting innovation in process and techniques in Mahendra Raj's work, which mark a crucial time in history. The structural drawings of Raj's projects are historic documents that hold the key to the many hidden processes and secrets of the structures he created. In addition to being works of art, they are packed with information, instruction, and infinite detail, revealing how tightly he controlled the building process as well as the design. The construction sequence drawings and notes we found in most of the large-scale projects, and even the not such large scale that I showed you, the NCDC, particularly the ones in the first 2 or 3 decades of his career, the 60s, 70s, and 80s, were very crucial part of Raj's work for 3 reasons, I'd say. First, the construction of the large span structures was a carefully staged process and meant analyzing the different structures that emerged due to the changing forces and shifting loads at different stages of construction. Second, the construction of these complex and large buildings with no previous precedents in the country or in the world, because the techniques were not available in the rest of the world, even if designs were possible. So really with no previous precedents, and with the rudimentary and manual construction technology of the early 60s and 80s, required instilling courage and confidence in the contractors, which was done through detailed communication through the drawings and of course, personally on site. Third, the notes helped analyze and resolve issues such as economy of time, material, and construction resources, and reduce the use of scaffolding and other materials. To quote the historian Mark Jassenbeck, his gift to bring to every project the magic of engineering, whether as a collaborative process and many times directly for clients, his innovation was imbued with a simplicity, which in his case is truly the ultimate form of sophistication, from scarcity and with a discipline of control. From his days in Chandigarh to Aman and Whitney to his days through the first few decades of the post-independence in independent India, he would still not give up till he found the most feasible solutions, even till the last few days of his life. Until he challenged and pushed every possibility and could come up with the most clearest and lucid way of taming those forces and taking them delicately to the ground. The works represented here are a global narrative of the international style of modernism, as much as of its specific manifestations in the local conditions of India. India lacked in material and technological advancements. However, the availability of cheap labor and the undeterred nationalist zeal and determination of the young building professionals to create a vocabulary of the built environment for a newly independent nations pushed them to stick their necks out and imagine the impossible. There is a particular headiness of spirit and collaborative energy in this juncture of Indian modernism that produced unmistakably iconic and sophisticated buildings and mark an important time in the history that must be preserved. Thank you. Should I stop share?
Thank you for that glimpse into these wonderful structures. Moving on to our first panel for the day for a different, almost behind the scene kind of lens through the eyes of those who marked with Mr. Raj in the last 6 decades. In this panel, we hope to uncover the work ethics, technical innovation of his work through stories and anecdotes from his office. From Mr. Raj's office in the 1960s, I invite Dr. Vasudev Nori. Dr. Nori will be joining us online today. Dr. Nori, chairman of Shirish Patil Associates Consultants Private Limited, is a civil engineer whose interests include conceptualization and implementation of innovative structural designs of a variety of structures. Sorry. Throat issues. He acquired Bachelor of Civil Engineering from University 1957 and doctorate from EPFL, Lausanne, Switzerland in 1965. Dr. Nori's contribution to the field of structural engineering has been recognized through numerous awards conferred on him.
And click on
Yeah, yes.
page. My most humble pranams to all the participants who are gathered here, and some of them on the line, some of them online. I beg your pardon. It's not going to be easy for me to say something after the variety of structures that have been designed by Mr. Mahendra Raj. So I will do my best. I would like to share my experiences working with him personally during the period of 1965 to 68, just 3 years, but I have learned many things from him. I consider it a great honor to share my experience working with Mahendra Raj. He set up his professional practice in 1960 in Mumbai. Of course, I was not there at that time. Iconic structures designed by him from 1960 to 65 are going to be discussed by several distinguished speakers that are scheduled to follow. So I'll skip that now. And Mandini has already showed this photograph of this amazing structure. Basically, it's called Bombay Motor and Cycles Garage. It was a single-story, two-story structure, and there are no drawings available, basically. The question is how to build a six-story, actually, office apartment. The story is very interesting. Sharif Molubhai, an architect that worked with Frank Lloyd, he became a businessman and wanted to add additional floors for office use. Mahendra Raj and Sharif had met earlier some years ago. He approached Mahendra Raj to help him to find some solutions. It is truly extraordinary how destiny brings these two people together for an assignment that was mutually beneficial. Fortunately enough, headroom was available to install pile foundations in the garage. Transfer girders stemmed from this new set of columns. Well, this is the Oriental Insurance Building. This photograph was just clicked by me recently. Unfortunately, the front view was blocked by some construction that is going on. So the office floors added by Mahendra Raj are a testimony to the visionary engineer that he was. 62 years have elapsed and the building is sturdy, just like Mr. Mahendra Raj was. So this is the time when I joined this company. Charles Correa returned to India after earning postgraduate degrees from MIT and setting up his practice in Bombay. At about the same time, D.V. Doshi, who returned to India after working with Le Corbusier, set up his practice in Ahmedabad. Charles Correa, D.V. Doshi, and Mahendra Raj working together on some projects. Mahendra Raj reminiscences that it was Charles Correa who threw up the idea that Mahendra Raj and Shirish Patel join hands. Mahendra Raj and Shirish Patel are not just brilliant engineers, but also great visionaries. In the initial months, they continued their firms in separate locations for some time. They together founded a partnership firm, Engineering Consultants India, and the office was shifted to Bharat Bhavan, Walkeshwar, which was large enough to accommodate the combined staff. Now, that is how Engineering Consultants India was born. Their individual practices shared several concerns: professional ethics, rendering excellent services that would meet the international standards, excellent library facilities, subscribe to the best technical journals, Indian and international, encourage reading journals and discussing the same every Monday morning, and encourage sketching and encourage innovation. I had the good fortune to work with these two brilliant engineers of our time. Mahendra Raj's projects were different from Shirish Patel's, but there was something for me to learn from each of these projects. We'll begin with this rather unusual project. This is a beach house for Captain and Mrs. Pereira. Raja Edri was the architect. He conceptualized the roof as an unsymmetrical hyperbolic paraboloid shell roof. The plan was kite-shaped, 27.4 meter long and 21.35 meter wide, supported on just 3 points, resulting in a cantilever projection of 18.3 meters. Now, I remember still very well what exactly happened. Mahendra Raj just called me to share the architectural drawing of this house. You know, I've been working with him, but we hardly knew each other. Mahendra Raj was holding a pipe, as was characteristic of him, and he had a very stern expression. Perhaps he was testing my educational qualifications. I was naturally very nervous, very, very nervous. This is putting it mildly. I was feeling cornered, and Candela came to my rescue, and warped surfaces have a charm of their own. So, well, I will not go into the detail. The shell was 75 millimeter thick with 300 millimeter thick edge beams. The doubly curved surface could be generated by straight planks. And the shell was analyzed by membrane theory, the differential equation that could be analyzed manually by the finite difference method. The whole process was very educative, and the importance of approximate methods could not have been better illustrated. Today, we jump to the computers every time. Now, it had many very unusual problems. This is a small project, but threw up new challenges. The site was remote, and last few kilometers could be approached only by a horse-drawn cart. It was a challenge for Mistry Premji Sundarji, the contractors, to transport the construction materials. And the design and the drawings were completed in about 6 weeks. This is a target Mahendra Raj had given me, and he was watching me almost every day what I was doing. Now, this is how we used to go to the site. We had to catch a boat from Bhauchadatta to Mora. That lasted some 75 minutes. When the sea is choppy, you would partially be drenched. So this is the shell when it was completed in 1966. The above picture was taken soon after the shell was decentered. And, you know, such a remote place, we prepared detailed drawings of the planks, the sizes of the planks, and how they should be supported so that they could generate this doubly curved surface just by straight planks and without any curved shutters. So, you know, house for Captain and Mrs. Pereira. Okay. Basically, if you see on the right-hand side, you know, it rises about almost 10 meters, and it is just supported on 3 points. And we use membrane analysis using finite difference method. Candela was my hero and my guru, I must say that. I've seen something similar in his book, and it gave me a lot of confidence. Hand calculation using slide rule, no calculators at that time. Something very unusual happened soon after the shell was complete. There was a paper was presented at an international symposium, and the same paper was reproduced in the Institution of Engineers India, and it claimed that Candela's analysis was wrong. I was somewhat surprised, and I again checked my calculation, have I done something wrong? But you can see Candela had a very neat way of solving the problems. Look at the plan. It is just symmetrical about one line, otherwise it's quite quadrilateral. So, but then you look at the elevation and you look at it from an altogether different angle. When you see on the right-hand side, it's a very simple rhombus. So that was the starting point, and it told us everything that what we had to do. So I checked it and I found Candela's analysis satisfied the check, which of course is very important, as Raj often used to say. The loads have to come down to the foundation. You have to track them down. They can't jump somewhere else. But the method presented at the symposium did not satisfy a simple static check. This is the problems of modern methods of differential equations. We get lost in the equations and lose sight of the problem. Well, this is the house at Uran. That was completed in 1966-67. There was a major challenge for me at a time when only tools in possession were slide rule, pencil, and erasers. I learned the art of structural engineering. I had the freedom of evolving designs and details. Mahendra Raj would meticulously check my workings. Well, a few years after the house was built, some cracks appeared and we were summoned. To make the matters worse, I explained that reinforced concrete structures do crack. Captain Pereira was very unhappy with me. But when I went to the site, the owners like to make all kinds of changes. And I was shocked to find out the normal waterproofing, which was very light, was replaced by brickbats and, brickbat coba, which was very heavy. And this had to be removed. And the shell was again granited as a matter of abundant precaution. In this picture, actually, I got it from Google, but I think it is not there anymore. I think the real estate prices being what they are, so this structure too has vanished, I think. Akbar Hotel, New Delhi, I think Madhana has already described that. Mahendra's own words, he visited Corbusier's office on his way to USA, and he reminiscences that he was cordially received. Being humble and generous, he expresses gratitude. This was typical of Mahendra Raj, having improved upon Le Corbusier's designs, remained ever modest and egoless. This indeed are traits of a true genius. As I said, Mahendra Raj visited Italy, and we met Nervi, and we liked some of the ideas. Like in India and Italy, the labor is very cheap, and it made a lot of sense to make these floors from ferrocement units, which were actually made manually. Another problem also described by Vandini, I discussed some of the structural issues, as you can see. First of all, it had several upper floors, and the lower floors must have a lot of free column space for the lobby and so on. So the spacing of the columns was 4.85 meters, 87 meters in the longitudinal direction, and 14.5 meters in the other direction. But it's not quite as simple as that. As you can see, it's punctured by stair walls, lifts, and so on. And architect, of course, wanted to have the same view from below. So we worked on that. In fact, I was one of several people working on that, or several people. But I initially worked with Mahendra Raj and used to come and look at several solutions. And at one time, we thought of structural steel, and many solutions were explored. But structural steel had this problem that people could not move in this floor. And in fact, even a major other problem was, since the main structure was in reinforced concrete, the connection between structural steel columns and the transfer girder can become very complicated. You can see it's complicated as it is, even with reinforcing steel. So that's how this idea of transfer girders in pre-stressed concrete came up. And we were working on that. Initially, what happened was, but if you, the bottom time member was very huge. It would consume a lot of concrete. So this was actually overcome by adopting stage pre-stress. This is just commonly followed in bridge designs. And the idea is just to do enough pre-stress so that it could support its own floor, maybe a couple of floors above. And so the pre-stress has been overcome. Then you add more floors, and the construction sequence was given. I think Vandana has shared with you. So this is the view. I think Vandana has already showed you. Very nice view, which of course gives sleepless nights to engineers. This is Indian National Theatre, New Delhi, architect Shivanath Prasad. So one of the main features of this building is 31 meter by 31 meter floors, supported on 4 cruciform shaped columns, spaced on a grid of 19 by 19 meters. Yeah, this slide, again, Nandini has showed you. This shows the connection between the floors and the columns. And it's quite a large floor, and the grid floors were analyzed using a computer program developed by us as part of Shirish Patel's group, thanks to a mainframe computer available at TAFR, which is available for private consultants for a fee. So, so I was quite happy with the outcome, but then there was another problem. Architect wanted an opening in the stage, a clear opening. We don't like cantilevers and creating too many complications. So I persuaded Shivanath Prasad ji to allow us at least just one beam which is connecting the column. And he was convinced, and in fact, he was quite happy with the number of columns Mahendra was received has reduced. So I thought, he was quite willing to give me a concession. So when Mahendra Raj actually, when he returned from USA, he was not in Mumbai at the time, otherwise he would not have done this. I was taken to task. He assured the architect that we would revise our drawings without any beams and the stage opening. This was typical of Mahendra Raj. He would never let a structural engineer compromise with the architect's aesthetic and functional vision. Well, engineering consultants in India finally had to be dissolved. Partnership had to be dissolved because by the end of 1968, we had very interesting projects, but money was always the problem. The financial situation became severely strained, and Mahendra Raj went to USA part-time, and at the same time managed to send some assignments to Bombay. This included preparation of shop drawings for structural steel building, a flat type structure, etc. American codes are written with great precision and clarity, which considerably simplified our task. And during that time, Shirish Patel was in charge of engineering consulting in India office. During that period, Mahendra Raj returned to India and decided to move to Delhi. That's where actually he started his career in Chandigarh to begin with. And the partnership was dissolved, and Engineering Consultants India became the proprietary firm of Mahendra Raj, being sole proprietor. Some of us working on the projects that were led by Mahendra Raj, and some by Shirish Patel at the same time. Both were brilliant engineers in their own way, and yet distinctly different from each other. I was indeed fortunate with these two, working with these two stalwarts. The legacy of Mahendra Raj. When one goes through his book, The Structure, one cannot but admire several iconic structures conceived by him. Yet, he spared his valuable time for the good of civil engineering fraternity. He founded Consulting Engineering Association of India. He also founded the Indian Association of Structural Engineers, and also the Engineering Council of India, so that civil engineering professionals would have the same status as other professionals. So we must take up this challenge and take it forward. I believe that this is the best tribute and homage we owe to Mahendra. And lastly, I'm truly honored again to speak, and I get sometimes very emotional. I'm sorry I could not make it to Delhi for health reasons, but the organizers were kind enough to allow me this time online, and how I hope you have enjoyed or somewhat enjoyed what I said. I don't know how clear my diction was. Thank you again and again. Namaskar to all of you. Thank you very much.
Thank you, Dr. Nori.
Thank you. Thank you.
From the 1970s, I invite Mr. Ganesh Juneja on stage. Mr. Ganesh Juneja is the managing director of structural consulting firm Juneja Techno Consultants Private Limited. The firm was started in 1984. He graduated in 1969 from IIT Bombay. He has worked all over the world and has been associated with number of iconic projects like Hajj Terminal Jeddah and many more all around the world.
Good morning, everybody, and thanks for your kind words. I have been given a Herculean task to speak about his structure. Most of them which I am going to speak are all through my memory, for which Raj always appreciated till he passed away, that I have an elephant's memory and I remember even my first project. So when he had any problem in his old projects, he would call me. So before I start, I would like to speak few words about my relationship with Raj, which started actually, I still remember the date, 25th September 1969. When I went to his office at Nepean Sea Road for interview, as guided by my HOD, C.K. Ramesh. And after 10-15 minutes, Raj called me. As Mr. Nori said, that was his trademark. He was holding a pipe in one hand and standing there. And unfortunately, we both were same character. He never used to wear undershirt and had always 1-2 top buttons open. And I still have the same habit. I don't know, when we both met, probably we struck a chord, which lasted till he passed away. Although I had left his office 46 years back. So then he started interviewing me, asked me a few questions on that, and suddenly he asked me, draw a bending moment diagram for a portal frame. And I messed up. So he said, look at it again, it's wrong. And see my audacity, I told him, sir, you have passed long back. At your time, they were not teaching you the sway part. Now the bending moment diagram is like this only. And he got up from his seat and he started laughing loudly. And few of the engineers came running because I learned later on that they had never seen Raj even smiling. His name was called as Fire Engine. He would not smile. He will go to, if he is walking in the office, even if you are not working, you will pretend you are working. And he used to always call me, you are a spoiled brat. But somehow, when after that, I thought he is not going to offer me the job. To my utter surprise, he said, when can you join me in Delhi? It was a real shock for me. But anyhow, I told him after a week. So I joined him after a week. When I came here, the same story, we were only 5-6 persons. They had shifted to the new premises, E12 Defense Colony from New Rajendra Nagar 2 days back. I joined on 3rd of October, 1969. It was a Friday. And I reached to his office around 10:30 because I didn't know what are their timings. So Atmaram, the late Atmaram, who was the office boy with Mr. Raj all his life since 1960 till he passed away. He said, Sahab aapko bula rahe hain. So I went there. He said, when did you come? I said, in the morning by train. Are you comfortable? Do you have place to stay? I said, yeah, my relations and a lot of relatives live here. He said, if you are not comfortable, let me know. Your batchmate is staying on top of the servant quarter. My batchmate, Krishna Hegde, was working with him for 1 year prior to that. He told me today, you relax. Look at the drawings. That time we had only one big project, ISBT. And we all three engineers were working on that. He gave me some part, but I was at that time pretty notorious and he would note that. But he never scolded or anything to me. One day he came, there was a test match going on in Delhi. And Ashok Mankad was scoring a century. It was the lunch time. And after lunch, I was listening in the lobby because I used to live hardly a stone throw away from the office. I brought my transistor and I was listening. We were only 4 or 5 guys. So the guys were signaling in slow motion, Sahab aa gaye, Sahab aa gaye. And I was so lost, I did not pay attention. And he told them, leave it. So after 5-7 minutes, he called me in his cabin and I thought today I'm going to be kicked out. The first thing he asked, what is the score? And has anybody scored century? I said, yes, Ashok Mankad had scored century. And that time, the colleague of Mr. Nori, Dayal V. Jain, was in our Delhi office from Bombay office. They had the partition done. Partnership was broken, but Dayal was working for Mahindra Raj, sitting in Bombay. So Dayal said, did he scold you or fire you? I said, no. He says, in Bombay, we dare not say anything to him, while you guys could talk to him such a way. Somehow our relationship was more like a spoiled son and father. Except Raj, probably nobody knows. In my 7.5 years, I must have resigned at least 6 times. And every time he would sit down with me, persuade me, and bring me back. So I really miss him till today. And I was fortunate that I met him, courtesy Rohit, that he was remembering me 4 weeks before he passed away. Now coming to structure, when we started, there was, like I said, only ISBT project. And there were some small projects. So after 1 month, Raj told me, you would be reporting only to me. That time we had chief engineer, design head, Mr. Parikh, and he was to leave within 1 month for states. So he gave me 1 or 2 small jobs. Then after 2 months, suddenly I get a call in the evening through his PS that tell Mr. Juneja not to leave the office. I'm coming back from NDMC office. It was about 5:45. And 6 o'clock, our office used to close. And Saturday, Sunday was off. So I waited. He came around 6:15. He had the bunch of drawings. He called me to his chamber. And he showed me this one, just show that. That was, unfortunately, that structure has been demolished, courtesy the development of metro station. That was Central Park, in Central Park, 120 feet dia fountain. पहली वाली run करो. This was the plan. Unfortunately, we could not locate any drawings of this. So yesterday with my memory, I got this plan prepared to explain this structure. Before this, I had never heard in undergrad what is a plate structure. So Mr. Raj explained me, and here I would like to mention this architecture was also created by Mr. Raj, not by any architect. He was the sole structural engineer along with architect. So this, as you can see, the columns are at 8, it was supported on 8 columns. which are at 80 feet dia, and the ribs are having 1:24 slope. And once it comes to the, just show one here, the section, after the cantilever, the slope was changed to 1:10, because by aesthetic, show the photograph. So these radial ribs are 6 inches wide and 2 feet deep. And there were tangential beams, 3 of them. वापस बनाने जाओ. हाँ. So there were tangential beams. At the column, the beam was 3 feet wide, because at that time, Raj was very uncomfortable with MKS. He would always do everything in FVS. He spent nearly an hour and a half with me. Half the things went over my head. And I was thinking, where I got stuck, everybody's gone home and he's holding me back. And next day was Saturday. And he said, come in the morning, I'll explain to you more. From Monday, you can start designing it. Reluctantly, I nodded my head. Raj was bachelor that time and used to stay on right above the office on second floor. First floor was the office. I knew he doesn't come before 10:15, 10:30. So I went there at 10:30. He gave me a book. Young man, he used to call all of us young man. Young man, go and read it. I spent 2, 3, 4 hours. Maybe I understood only 20, 30%. Then he came back after lunch at 3. He said, what have you understood? I told him little bit, this is not bad, but you got to read more. And then he said, okay, now you can go. It was 4 o'clock. So Monday morning, he came and he said, I know you didn't like Saturday, as well as I was forcing you to study. And he said, all right, I will make your life simple in native language. He used to talk to me in Punjabi most of the time. And he gave me handbook by Rourke, and which had all the coefficients for the moments in the radial ribs, as well as in the tangential beam. And he says, you can certainly design, you are smart enough to design the cantilever. So I said, sure. And that time, the codes were very primitive as far as the seismic loads were concerned. And 4, 5, 6 was also not very elaborate like it is today on so many codes. There, our seismic was for daily 5% of lateral load applied to plane frames by portal method or equivalent frame method or central portal method, and get the moments and provide the same moment at the junction between the beams. And that was it. Later on, when this computers and all came, we found that they were much more conservative, because with the time factors, usually in a little bit higher buildings, the force is reduced. So then after I designed, he sat down with me. And here I can say one thing, that I have worked all over the world, and I had the fortune of working with the greatest engineers in the world, like Fazlur Rahman Khan, Mario Salvadori, David Geiger, Lev Zetlin. But I found nobody who was that methodical or clinical, like an artist in detailing like Mr. Raj. Because he was the engineer for architect as well as for the site. He was very particular, especially of the junctions. He would always want a sleek, thin elements. Like they all said, aesthetic was his main forte. So once we completed within a month. And then he said, you should go to the site every second, third day. I had no vehicles. He will pay for a scooter. I would go. It was so cumbersome shuttering that Tirath Ram Ahuja was the contractor. That time he was way ahead of even L&T as far as the building work was gone. And they put up a ARA machine there and did all the shuttering right there. So once I completed this job, fortunately, we got Dhasna. Dhasna, इसकी slide के जरा भेज. ये तो डेरी आ गई. हाँ, Dhasna. Second करो. They all have shown the pictures, just show the drawings. So we got Dhasna, and Raj used to work at home in the night also. And like they said, 10, it was not 10. Actually, it was 12 systems he had created. He would call me always as I was good in numbers because there was only slide rule. To run the slide rule, after an hour or so, he had written down, then he would say, did you understand anything? I would say, no. He said, come around me. He will explain why it is being done. So whatever I learned actually was after 6 o'clock, although I used to resent, he would sit down, force me literally to sit up to 8:30. And Raj used to live on the same office premises. So he had told his cook that if Ganesh is sitting after 7:30, you will see to it that he takes dinner and then goes on. So for another 4 or 5 months till he got married, I used to take my dinner at his place. So in Dhasna, I didn't do much initially. He made those systems. He would come in the evening, morning, give me those half a sheet. He will tell me, get these sketches made from the draftsman on the tracing, and you calculate the quantities. So when we were planning, like Rohit said, it was not twin arch, it was single arch. And at the time of planning, the columns were at 30 feet center to center with a roofing of double T's, which became 40 feet because once he started, and our competitors were that time, they were who were trying to get this job was Mr. Ramesh Chandra of Unitech. Raj gave them so many systems. He took me when the day he presented them and gave them the cost and proved it that without having any column in the middle, the cost is not much variation, maybe a couple of %. And that got him the job. And he was very, very happy. And we started working. That time we had only 5, 6 engineers. And he was looking for, and suddenly he hired 2 engineers. One was senior, Mr. Shibendu Paul, who was just back from Canada after doing masters. He was already MTech from BHU, and he was teaching in BHU before he went to Halifax. Raj visualized that he will be very good for doing the analysis because it was all manual. So Raj said, we have to give the foundation very immediately. You sit down with me for 3-4 days. We will design the foundation. So then he started working and he came out with this twin system. The columns were at 11 feet 6 inches center to center. And the span was 157 feet. I remember because we were working on the FPS system. The arches were 15 inches wide. The box girder was about 12 feet and 5 feet deep. And double T's were spanning around 30-35 feet. So he used the number of books and got the coefficients and took out moment, shear approximately, and asked me to, he was very particular about the loading. And he always advised us that if you can follow the load flow and you are able to get column loads accurately, you have achieved 50% of the design. So then within a week or so, he was doing the major work. I was doing side rule mainly. And we issued the foundation drawing. There was tender. Raj never wanted the project to be given to the contractor, Ratan Singh and Sons. He was favorite of DCM. Raj wanted it to be given it to Gammons. But he was lowest and he was quite close to the Bharatram. So they awarded him the work. And the result within 1 month was that he could not work more than 10%. For the arch analysis, which I did not do it, which was done by Mr. Paul. And for that, Raj evolved a system in which there was very minutely compatibility of strain of different hangers in the arch. For that, he took out an ancient calculator, mechanical calculator I had seen first time. It was like a typewriter. You punch the thing, punch the what you want, multiply, then pull this lever, then add another, then pull a lever. So it was 8-digit. It was 8-digit. And Paul took nearly 2 months to do that. By that time, within 1 month, they were not able to achieve even 10%. So they requested Mr. Raj that we want to be completed in 1 year. Then Raj talked to Hingo Rani of Gammons. And they agreed to take up the job. And they said, all right, 1.5 months is lost. We will still do it in that period. You throw us a bonus clause and penalty clause. So they did it. So Raj, like I said, we had a different bond. Even if I was not involved on the job, he would take me to the site. So when for this site, he took me, the water table was, the project is very close to Hindon River. Water table was at 2 feet. And footing is around 7-8 feet down. They would dig the pit, put the plates. By the time in the morning they came, half the plate would be in and water will be filled up in those pits. So the contractor was quite nervous as well as losing. So he gave up the job without much of a fuss and Gammons came in. And then DCM that time was having a lot of management trainees, mechanical, electrical. They put all the 20 engineers on their site. There were 2 halls, 157 feet by 750 feet. So 3 engineers we were working. And Raj sat down with all of us and detailed all the this junction. Raj nearly told us, draw the full scale column. Columns are 100 inches by 38 inches. And the truss is about, this arch is 5 foot 6 inches deep, which becomes thicker on this. And twin columns are 12 feet center to center. He made us draw this. See, you see the reinforcement at that level, because he made us draw the complete bending moment diagram at nearly every 5 feet and made us design at least 5-6 sections. So at the bottom, you will see reinforcement is not that high. As you go higher, it keeps increasing in the top junction. And whatever I do the detailing, I think I have learned from him only. And he said in the beginning only to me, Beta, you may miss out something in design, but if you have detailed a building very well, it will stand. But you may do very good design, and if it is not detailed well, chances are it will not stand. And he was very particular about the junctions. Right after this job, the third job came, and I was somehow associated somewhere major, somewhere minor, but most of the jobs, but by now, we had around 10 engineers. When I joined, we were only 3 engineers. We had around now 10, 12 draftsmen. And by 73, we had about a staff of 25. And in 75, we had a staff of around 50. So next came after this. This building is unfortunately, it is still standing, but in very depleted condition. I think you all have seen, and we all call it a Khandhar. It is 14 Barakhamba Road, right opposite modern school. This was a fantastic building. As you can see, you will never see these kind of column. I picked up this building only for that reason. These columns are around 11 feet 6 inches wide. On the perimeter, the spans are 66 feet of these beams and 44 and 66 feet. And this building, we started by end of 1970. By that time, there were some computer programs available in India. And Raj found out for this building, he said, we should find somebody who can do the computer analysis for that. Still, the mainframes were there, but still they were in pretty primitive. They would only do plain frame analysis. The system was, as suggested by Fazlur Rahman Khan, that all the frames, you put it in series, shear wall frame, connected by the links, which had lot of area, but no moment of inertia. The philosophy was that the building deforms, deflection is same, that will give you the distribution in all the elements. And it was only plain frames. So we found out that Dr. Satlur in IIT Kanpur has the program on the mainframe, and he said he can do the plain frames, but he will need somebody to sit in IIT and give him the data. As I was enrolled, so I was deputed to IIT Kanpur. I stayed there about 10 to 15 days. My duty was nothing, give him, because this shape was not possible to be fed. So we had calculated I and area of these elements, we'll give it to him that. In the perimeter beams, these were basically 5 feet 6 inches beam, 2 feet 6 inches below the flat slab, and 3 feet above the flat slab. That is forming the sill. And we had flanges and top and bottom for this span, and they were only 9 inches thick, that it should not buckle. So Mr. Satlur, after 15 days, gave me this thick bunch of output and guided me how to read that. While I was there, my duty was he and his wife, both were computer analysts also, both are civil engineers. He would write the coding sheet, his assistant will punch, and if he got stuck, because the program will stop, then they will take out the card, he will tell me, young man, just check what is the mistake in this. And that was my duty, nothing else. So when I came here, we started the piles. We finished the piles for this job. This building was 22 story above the ground and 2 basement. That time, this area was permitted for FAR, which the Hans Plaza, which is right opposite this building, has achieved. But this building was somehow unfortunate, but that we awarded the tender to Simplex. But by that time, they were about to move, and the owner, Baba Dan Singh, had a very bad reputation in market that he does not pay. And that time he was one of the richest person in Delhi. So they did not start the work. At that time, right after this, we got the trade fair. Raj came back from States. It was the month of July, 1971, June or July 71. And he said that we have got Pragati Maidan, and we all staff have to work on that. So we were 6, 7 engineers working on it. And this was a space frame. So he said, "Haath se to hoga nahi ye." So then his old colleague of Mr. Nori, Mr. T.T. Fatehi, he's alive, he's a genius. He said that he can get this space frame analyzed at Tata's. One of my senior, Mr. Pandit, was working with them. So Raj said, all right, he assigned Paul to go to Bombay and supply the data to Pandit. Paul stayed about 30 days and he got the result. Inside this, दूसरी picture दिखाना. हाँ, वो पिछली. Inside this, there is a mezzanine, which was 64 feet cantilever. Centrally, it was a L shape. There was only one column in the center, 8 feet dia. So Raj and I designed. His philosophy was very simple. He says, beta, the total cantilever moment will not change. Total moment between the column will not change, positive moment and negative. It's only the computer will give you a better distribution. That the strip which is coming close to 8 feet columns or 12 feet will have much more reinforcement compared to the end ones. So we made the framing of this and the drawings, which Raj suggested X percentage in this, Y percentage in this. The only thing we could not figure out, which was very intricate, was the torsion in the beams. So he called Pandit, said, send your engineer for a week. I think we will be able to do it. So I went for 1 week to do that. Once I brought the results, to my utter surprise, the distribution in the beams was not much difference than what Raj had done with his experience and manually. The other thing in this mezzanine was the detailing, which was a Herculean task. Because in 15, 16 feet area, the steel was, this was all waffle system. The steel was so heavy that if you place equally spaced, there was no way the concrete could go. So Raj sat down and he said, leave only 2 inches gap at the top. Then at every 18 inches, create a pocket of 12 inches by 12 inches, where from the concrete can flow. And we did that. So the contractor, unfortunately, did not see that. He placed all the reinforcement uniformly placed in that column capital area. There was no space for the concrete to go. Mr. RAJ was the chief engineer, and the contractor and Axion complained, this is the design their consultant had given. How can we pour the concrete? And these waffles are 1 meter deep. So then Raj took me there. He says, what is the problem? Do you know? I said, there is no pocket there. Because on this job, fortunately, I was the only one beside Raj who was having a 2-wheeler. Raj had the car. So it was my duty for trade fair to go every day to the site and find out what is their need or where they are facing problem. And as far as these elements are concerned, this was 457 feet by 457 feet. It is springing only from 8 points. And all these 8 points are connected by the tie beams, which are pre-stressed. They are 457 feet long, and we have a small below the plinth, small columns to support that, so it should not and the width of this was 450, and depth was also, I think, 400 of, this was pre-stressed. And like Rohit had already pointed out, Raj got the analysis done that after level 5 only they can release it. All the joints were supported, and first stage of pre-stressing was done. We used Gifford-Odle system where individual strands are. And here the biggest problem was the springing point, and everywhere the angle was 57.3 degrees. And the joints were the most difficult part. I think I will be failing if I did not give the credit to the draftsman who did this. I don't think I would have been able, even after explaining by Mr. Raj, we would have been able to detail it if that gentleman had not the imagination and drawn on the drawing. He understood better than us every joint. His name was Devinder Singh Chadha. He was doing NDR. And he would guide us all the joints that here 8 members are meeting, here 9 members are meeting. These are all of, so all these springing point, 4 springing point. I still remember I went with Kuldeep Singh. These bars which are coming out, they were 1 degree less. There were 20 guys, these are 28 dia bars. There were 20 guys with the rope hanging, trying to bend it 1 degree, and they were not able to bend. And Raj had said, no, I will not permit heating of these. With great difficulty, with lot of hammering and all, we could achieve that angle. And there were a lot of what you call galleries for inspection in between. A number of panels were granited. But unfortunately, after 3rd, 4th level, the quality went down and it had all kinds of problems. So here I learned there were another 3 structures which we did here, and unfortunately, none of them is anymore in, it has been demolished. The one was Nehru Pavilion, which was a inclined portal by Raj Rewal. Another was Textile Pavilion. Textile Pavilion was where I was introduced to the retrofitting of an existing structure. It was earlier a government building with small rooms with 9 inches of partition wall. The roof was precast panels done by there. So everything, Raj guided me how that we will not do the foundation, use the same foundation and create columns. Total textile pavilion was given that shape. After this, the last job came, but in between there were dairies. And I did all the 4 dairies, Delhi, Bombay, Madras, and Calcutta. The main feature in this was only 2. One was the folded plate, which I had never done. And Raj could get it done from an idiot like me. And I did for some feeder balancing dairies also. Back karo beta, kya kar rahe ho? Iske piche. Dairy kahan se le gaye the? Haan, ye. So, as you see, one was folded plate. It was a total process hall, which was 30 feet. Uski drawing kholiye, yahan pe drawing hai uski. Or this folded plate, if you see, this is only 5 inches thick. And this span was about 32 feet. And at every 30 feet, we had these beams. So when he asked me, and the way he explained it, it turned out to be very simple. But when he said we will do it in 5 inches, I said, are you sure? Then he said, you are talking to me like that when the way you talk to me in interview. And he would tease me whenever he got the chance, whenever I question him something which was stupid, he would say, you are talking the same way. So this was, and I made a lot of visits to this. And unfortunately in Calcutta, if you see the building, see, this was an admin block. This is the main road. where all fire tender and milk tender tanker comes. So we had to have these 2 floors above that road. This was about 40 feet. These are non-pre-stressed girders. So it was 2-story cast on this. And when we were doing this, we did in 72, 73. I used to travel a lot to all these 4 cities. And by that time, we had started feeder balancing dairies also. And they were at so remote places. For Vijayawada, we went by train up to Hyderabad because there was no flight. Then to Vijayawada by train and to the site around 5 kilometers before that by bus, and then by bullock cart, where they were making this. So it used to take 2 days to go and 2 days to come back. But these structures taught a lot, and they were my turning point for the future. The next was the last job which I did before leaving in 76 was Hotel Moria Phase 1. This was the building having 3 wings and on the 4th side a banquet hall. The lobbies of all the wings are 50 feet wide. So we had transfer girder, boat shape. इसका transfer girder दिखाना और यही होंगे हाँ यही है पीछे वाला हाँ we had 2 types of transfer girders and these are pre-stressed bottom chord. The bottom is only 1 feet 6 inches deep and about 2.5 feet wide. The second one is it springs from the column as a straight, then it splits in 2 because in the rooms you have to have a shaft for the toilets. So Raj created that, but he wanted precast roofing system, and we went to Hindustan Fab. Mr. Salve was that time the head, and he refused that they will be able to deliver. So Raj invented a system where we made ribs, where the bottom of the rib was cast just, and the steel was only in center, the nibs were there, and we cast at side hollow blocks, 18 inches wide, and those hollow blocks were resting at the nib of the rib, and then the ribs were cast, and on top of these hollow blocks, we had 2 inches of topping. That is how we achieved this lot before the time. And this structure also this is actually on weathered rock. So when we started excavating it, we found half the area is on the weathered rock and half area is on the earth. Raj said, let us do it for the earth only. Forget about the rock. It will be oversafe, don't worry about it. And that's how this structure came up. And I completed this job in the beginning of December, and I left. And but our relationship, fortunately, never ended. Because after I went away to Tehran, and he came to Tehran after 4 or 5 months, and we met a couple of times. Then I came to India, and I was going to States after getting married. He could not make it to my wedding, but then he called me. He says, you are going to States, so go and meet my friend Abator. Because in the States, you may be the best engineer, but you will not find job easily if you don't have references. And so I went there and I met Mr. Abator. In later years, Mr. Abator became my colleague because our company bought them out. And he worked with me nearly 4 years. And with his actually reference, I got my first job with a company, you can say a dream job, because I had seen air-supported roofs, but I never dreamt that I will ever have a chance to work on them. And my first job was that with Geiger Berger. And I was given the first job with air-supported roof, Carrier Dome in Syracuse, which was about 9-acre roof without column. And I learned there precasting, the maximum. And I was fortunate that right after design in 5 months, the client requested that I should stay at Syracuse. That taught me a lot of material being used in the United States, construction techniques. Of course, it was very lucrative financially also, because client was bearing all the expenses, including car, house, food, everything. And Raj came in 1980. By that time, our company had bought his friend's Abator's company. So he called me and we met. We had a couple of time drinks. I took him to my house. He stayed one night. So then he was very keen. He said, I see you guys are working on tension. That time where work was going on a Hajj terminal. So Abator had told him the structures we do it. And Raj was very keen to have a LOI with our company. Abba said that you want this, ask Ganesh, because they don't call you with second name, they call you first name, and they can't call Ganesh, they call you Ganesh. He says, Ganesh and David are very close, more than me even. So you ask him. So I got LOI done with Raj without any terms condition, but unfortunately in Asiad, he could not use that. So whenever I came to India, I met him and he always wanted me to come back. And here, although it is out of place, when I left, and I knew Raj gets emotional. So during my farewell party, I told my staff, if Mr. Raj is coming, I would not attend the party. So they did not call him. And after the party, I went to him. The first thing he asked, party nahi hui? Main you didn't throw the party. He says, no, tell me. I said, yes, it is done, but I requested them, you should not come. He says, why? Because it's never pleasant when you start emotional things that why are you leaving, this, that. It becomes very difficult, hard for the person who's leaving your organization. Then he said, all right. So I touched his feet and he said, Gale milke nahi jayega. And he started crying. I still remember that. And he said, I never thought Ganesh will ever leave this office. I thought you are going to own my office. I said, sir, life moves on. I have to also move on to get experience all over the world. And when I came back, we used to meet quite often. And I have no shame in telling that he told number of clients when they were thinking whether they should give me the job or not. And Raj said, you won't repent. There was an American architect. He was friend with Raj. And he was sitting and having dinner with Raj in Raj's house. And he asked him, do you know this boy? He says, yeah, he's like my child. He says, how do you rate him? And Raj and me both were trying for that job. I did not know that Raj was in the fray. So Raj told him very politely that you will never repent by giving him the job. And I don't think I could ever say that for him, to be honest. He was great. And I miss him till today. And thank you all for listening to my being patient and listening. Thank you all. Thank you.
Thank you, Mr. Juneja. From the 1980s, I invite Professor V.K. Dogra on stage. Professor V.K. Dogra is head, School of Civil Engineering, Shri Mata Vaishno Devi University, J&K. Dr. Dogra has worked with Engineering Consultants India from 1988 to 2004. In 2004, he joined SMVD University as a university engineer, and in 2007, he shifted to teaching in the School of Architecture and Landscape Design. He has worked on many large span shell and folded plate structures.
Good afternoon to all of you. Mr. Juneja has talked a lot about Mr. Raj, and I support that Mr. Raj was just like that. I spent a few years with Mr. Raj. I started working with him in 1988, and I worked till 2004. And during that time, I learned a lot from him. So I would like to share my first meeting with Mr. Raj. You see, I was walking from Arkepuram to Lajpat Nagar, and it was evening. When I reached Sarojini Nagar, I just requested for a lift, and a van stopped. I boarded the van, and it was Mr. Raj who was driving that car. With him, Mrs. Raj was sitting, and I sat in the rear seat where one another lady was sitting. So on the way from Sarojini Nagar to Mulchand, he kept on asking me various questions. My name, my place of stay, what am I doing, etc., etc. But I didn't ask anything because I was just interested in the lift. And I got the lift and I dropped on because I was just passed out. I passed out in 85 and I met him in 86. So when I was, dropping off, he asked Mrs. Raj to give his card to me. And Mrs. Raj gave his card to me and said, he is one of the top engineers of India. But even then, there was very little time and the car moved ahead. So I took the card, put in my pocket and went to my room in Lajpat Nagar, where I was living with a few more civil engineers. And when I showed them the card, they were very much fascinated. Oh, you have met Mr. Raj, Mr. Mahendra Raj. He's a renowned structural engineer of the country. You should go and meet him again. And, he can give you a job. He'll make your life and like that. So next day morning, when I had come to know that it was Mr. Mahendra Raj who gave me the lift. So I went to his office, I met him and I expressed that I am interested in structural design. So he called Mr. J. Ghosh and said, he is our Mr. Ghosh. He will interview you. And if we find that bending moment and shear force are in your head, then we'll consider you. So after a few days, I appeared for the interview. I was selected, but I couldn't join him at that time. So this is literally, I joined him in 1988 after working with Mr. Y.N. Diwan for nearly 1 year. So while working with Mr. Y.N. Diwan, I did lots of jobs because with him, job was coming in the morning, going in the evening. So I did slab design, beam design, column design, and learned a little bit of design. But I couldn't get the experience, experience in the sense that I didn't have the confidence to design a building. If anybody approached me, I didn't have the confidence because I was only doing the designing, never worked on the drawings. So the drawings he was taking care of. Now, my first project with Mr. Raj. So when I joined him in 88, I was given a job. I was made to work with Mr. Vinod Mutneja as senior engineer, and it was the fruit and vegetable market. Mr. Kuldeep Singh was architect for this, and there were so many folded plates, pyramidal roofs. I'll just show you a photograph of those roofs. So these were like these pyramid roofs. So I had the, experience of designing slabs. So I thought like we design the staircases, the folds are there, but we design just take a span. So I designed these as simple beam and slab. And when I designed these as beam and slab, my beams were becoming very heavy, lots of reinforcement. So one day Mr. Raj looked at the drawing on the board and he called me in his office. So when I went there, he started teaching me the slab behavior, the plate behavior, and the in-plane forces in the folded plates, etc. And then he said, okay, you take that book, read that book of Swami and find out how the stress distribution is done. So then, that's how I learned this folded plate structures. And after that, I designed a lot of folded plates in fruit and vegetable market, in the common facilities block, which were at Coimbatore. These are some drawings of the fruit and vegetable market. These are some photographs where the folded plates had the cutouts. These are the cutouts visible. And then means lots of folded plates were done. Now the second project after this fruit and vegetable market was CMC Hyderabad. So Mrs. Design Plus was the architects, and there were lots of shells in that. Phase 1 was being built. In that, one dome came up. And, generally we were placing the domes either on the rooftops, on the slabs or on the edge beams. But he sent an architectural drawing where the dome was not resting on the beams. It was resting on the slab, which was extended, from the beams. And when that came, I just found that the dome is resting, point load is coming on the cantilever slab and there's not sufficient of backup. So I said, no, this is not possible. So Mr. Satish Gujral wrote a letter to Mr. Mahendra Raj that to intervene into it, because he said your engineer is not agreeing with this dome, and I want this because that dome was right at the entrance of the building. So then, a few days after that, sorry, I have gone little ahead. So in this, in CMC Hyderabad phase 1, there were shells, and the auditorium roof was made up of shells. So this is the, 2 blocks are there, which are the auditoriums, and there are 3 shells you can see, which are spanning from 25 meters to 35 meters. So in the architectural drawings, the sections of the beams, which are, connecting the 2 shells, were very deep, something around 600 by 1200. But when we design these as finite element, we found that those so much deep beams are just adding to the weight on the shells. So that was reduced to 400 depth. And we designed, and the drawings were sent for construction. L&T was the contractor, and he wrote back that our structural engineers have checked the design and found that the beam depth is inadequate. So please look into the design. So I was thinking that now how to convince them that this is, a shell structure and the depth requirement is not very high. So I went to Mr. Raj that they are saying like this. He said, you just reply to them saying that please check the design as shell structures and satisfy yourself. So when I replied that, so there was, they were quiet and the structure got built. So here we had shells which were, maximum span was 35 meters. Now, after that, phase 2 of this came where I was talking of the dome. So that dome was something, at the entrance of this. This is a Google image, so it's not very clear. But right at the entrance of this, there was a dome and it had to be visible from bottom also. So it was not on the flat slab. So the slab was cantilevering out and then the dome was to be placed on top of that. So when the information letter came to Mr. Raj, so after a few days of that, we were traveling, and we were in the aeroplane and I was sitting in a different seat, but I found that Mr. Raj is, the adjacent seat to Mr. Raj was vacant. So I went and sat with him over there for some time. And, he took out paper and draw the shape like this. He said, we have, if you look at the left-hand side, he said, if we have a structure like this, on the left-hand side, it is not stable. But the moment we apply a horizontal force, if you can get a horizontal force, the sketch on the right side, you can see. So it becomes stable. And then I realized that, yes, we have a dome which can provide the horizontal reaction. And the horizontal reaction can be taken very well by the octagonal, beams which are all around. So I realized that, yes, it is possible. And then I designed this dome and what happened? It's not going. So then this dome, you can see, this is the dome where the support is little far up and the slab is having two bends. And then on top of that, the dome is constructed. So finally, this was built and these are the drawings of the dome. Then came the project Bharat Diamond Bourse Mumbai. So in this project, I learned a lot, design of so many different elements of the structure. So first of all, then the thing was that the client was Gujarati and the diamond merchants, and they had shortlisted two architects, architect B.V. Doshi and architect Charles Correa. And our Mr. J. Ghosh told us that whosoever is the architect, we are confirmed as structural consultants. Because if Charles Correa is the architect, we are, we will be consultants to him. If B.V. Doshi is architect, we will be consultants to him. So means the structural consultant was confirmed before the architect was finalized. And then, there was the requirement of construction of diaphragm wall. So I had no experience. I didn't know even the word, the diaphragm wall. And Mr. Raj, took out some drawings, which were very old drawings. He had prepared for some harbor structures and he showed me the drawings and then he gave me the, told me the stability of the diaphragm wall and the calculations of the diaphragm wall. And then, I started designing the diaphragm walls. Since at the site, the rock level was varying and we wanted that the diaphragm wall is, put into the rock at the bottom. So I was, sent to Mumbai that based upon the depth of the rock available at site, the diaphragm wall was designed and the drawings were issued to them. So I learned the design of the diaphragm walls. This is one of the drawings of the diaphragm wall. And the plot is shown over here. This was a 20-acre plot, which is at trapezoidal. And the client wanted to build, a double basement in whole of the area. And then there were 7 towers of 10-storied to be built inside. So the diaphragm wall was completed. And then I came back. Now, in this building, the architects, the client's requirement was that they wanted to have natural light in each and every office. So the architect decided on the width of the building to be just 16 meters. The column spacing was kept as 8 meters in whole of the project and in both directions. And to have a space of 16 meters, we had to have 4 meters of cantilevers. The floors supported on 2 columns, 8 meters and 4 meters cantilever on either side. And the flat slab system was decided for whole of the project. Now, to make 4 meters cantilevers in flat slab, without beams was the task. And Mr. Raj asked me to design the flat slab as this cantilever, and then he asked me to calculate the deflections with respect to the cracked moment of inertia. All calculations were done manually at that time, and then drawing the M over EI diagram with respect to the cracked moment of inertia at different sections of the cantilever and calculating the bending moment at the tips of the cantilever. So we found that the deflection was coming as more. And then, considering the effect of creep, the deflection was coming more. So the thicknesses were revised. And this is the plan showing the, flat slab. So for the cantilever portions, we had the thicknesses which were different from the thicknesses of the other area. Generally, when we did this LIC building, there the thicknesses were 200 thick slab and drops of 50 millimeters. So that made the thickness as 250. And then the second drop was 150 millimeter more. So that made 400 depth. So we had 200, 250 and 400 millimeters of depth. And here also, we started with that 200 millimeters as the slab thickness, and then 275 or 300 mm as the thickness of the first drop, and the second drop was made as 500. But in these cantilevers, what happened? Just to control the deflection, we had to work out, so many combinations were done. We increased the steel and then checked the, deflections, but we couldn't control. So later on, we had to increase the thickness. So the thickness, you can see clearly from here, on the cantilever side, we had to extend that 500 deep portion up to 3 meters. And then we had 250 thickness towards the cantilevers, and inside, where the central corridor was there, the thickness was made as 200. So, I mean to say that this all was under the, guidance of Mr. Raj, because he made me to work like that, and I learned out of it. Then this is another plan showing the, flat slab. Now, another thing that I learned in this was the transfer girders, the design of transfer girders. Now, in this, there were the requirements of fire tenders moving through the building at the ground floor. So we had to eliminate one column. So we had, 16 meters transfer girders were required. And then somewhere where the these fire tenders were moving, in the diagonal direction, we required transfer girders which were 23-meter deep. Now, it is very simple, everybody can design the transfer girders because we have the point load, we have the bending moment, we have the shear force, and we can design that. But what additional things Mr. Raj taught about the transfer girder is the use of inclined bars as shear reinforcement. In addition to the vertical reinforcement as shear reinforcement, he was always insisting on the use of inclined bars. And I'll show you the sketch. So these inclined bars were used in each and every girder, whether required or not required. The second thing is that we always were using the face reinforcements. The codal requirements are to provide the face reinforcements if the depth of the beam is more than 750 millimeters. But in the transfer girders, he insisted on putting the reinforcement in the body of the girder, inside also. He said, this will control the shrinkage cracks within the body of the girders. So it is something which is not there in the codes that you are required to provide. Then in this building, at one of the locations, there was the requirement of a Berendial girder. And generally, the floor-to-floor Berendial girder supports two floors, the top floor and the bottom floor. But here in this case, we had to support another third floor, additional floor with the help of a suspender taken from the Berendial girder. So Mr. Raj took out the drawings of the State Trading Corporation, building and showed me the design, the drawings, and then explained me the design of the Berendial girders. It's how the forces get transmitted. And I was able to design this Berendial girder. So, I learned so many different variety of things out of this project. Yes. Yes, yes. Yes, because the transfer girder, is the one girder which generally we take that it is supporting all the floors above. But that doesn't happen. So far as the construction is concerned, we do design, we make the transfer girder and then we add another floor. The other floor, is supported on this transfer girder. But what happens when we are making the next floor above that, the two floors start acting together. And the lower floors, which are just above the transfer girder, they were attracting more negative moments as if they are part of the transfer girder, as if Berendial girder. So we did that analysis, and that was considered in the detailing. Design of the shear walls. Shear walls we provide, but there is no specific, at that time, there was no specific, the design formulae. Either we were designing the shear walls like columns or, by maybe, I don't know, other methods. So Mr. Raj handed me over his calculations of designing shear walls using ACI code. And those calculations, those were in FPS system. So, those were used for designing the core walls. In these buildings, we had 3 cores, because these were very long towers. So we had 3 cores, one on the western side, known as West Core. We had a central core, and we had an East Core. So the design of the core walls was done using his methodology, his formulations. And that was done in FPS system. So we converted the loads and the forces into FPS system. calculated the steel in inches, and then converted the steel into centimeter squares and provided in these shear walls. So these are some drawings showing the reinforcement detailing of shear walls. These are some photographs of the Bharat Diamond boards under construction. It was a huge complex. There was 28 lakh square feet of area in the basement and 28 lakh square feet of area in the towers above the basement. This is another photograph of the same where you can see the porches. These porches, you can see, are cantilevers of 8 meters. They are 8-meter cantilevers. And there is space for the transfer girder movement underneath. There is a girder supporting a floating column and the cantilevers on both sides. These are some plans, the towers were long towers. But the width of the slab was restricted to 16 meters only. This is another project, this is Zansa Noida that I did with Mr. Mahendra Raj, and Mr. Jasveer Sani was the architect. And this comprised of 10 meter by 10 meter square blocks, which were connected at an angle. So you can see the triangular portions created because of the connections. Now, the special feature in this block is the, shape of the beams. We have the beams, the column spacing is 10 meter by 10 meter in both directions. And we have the ribs in between, 2 ribs, which are supported on the edge beams. And we have the beams which are supporting these ribs. Now, the shape of these girders are such that we have shallow depth at the support near the column, and then the depth is increasing when we come to the middle, and it is supported with an inclined member when it is the edge girder supporting member, the main beam. The ribs are having the same shape, but there is no inclined member supporting them. So they are just spanning 10 meters, the cross ribs, 2 in each direction, supported by the edge beams. Now, this inclined member support is providing space for services. So all services pass through this. And since the profile of the interior ribs and the girder are the same, so there is no obstruction. So you can see the sections. The ribs are wider and shallow at the supports, and their width reduces towards the center and the depth increases as per the requirements of the bending moment and shear force. And this was an interesting feature of this Zansa Noida. So you can see the detailing of reinforcement in these beams. And these are some photographs. So the exterior edges, finally we didn't keep that opening in the exterior edges of these beams, although the shape was maintained as the same, but we closed it because there was nothing required to pass through that. But the interiors are all open. The cutouts are there. So on top of this, there were conites. So those were simple. Now, another project which was done, and that was a group housing in Laburnum. So here we used the Maiwan system because we had 3 towers that were to be built, and these were 18-story towers. And For this, I think it was the first time in India that Maiwan system was used. So what is that we cast the slabs and the columns together. So we had thought of achieving a cycle of 7 days per floor, but we could achieve a cycle of around 10 days per floor. So with that Maiwan system, all reinforcements of the columns were tied up, and then they were inserted into the shuttering. After the shuttering is done, and then the reinforcements are placed in the floor and they are cast. The same system, the shuttering can be lifted up from below with the help of cranes and put on the top. So, because innovations, Mr. Raj was, always eager to use the best possible systems and innovative in the structural designs and construction. So these are the photographs of this laburnum tree blocks, which were constructed using this Maiwan system. So thank you.
Thank you, Professor Dogra. From the 1990s, I invite Mr. S.S. Maan on stage. Mr. S.S. Maan is currently the director of Mahindra Raj Consultants Private Limited and has been working in the firm since 1990. He has designed a wide range of structures in India and abroad built primarily in RCC, steel and masonry. These include large span structures and many landmark buildings, including convention halls, exhibition halls, sports facilities, high-rise, museums, hotels, and industries.
Thank you, Rima. Thank you, ISC President, Mr. Moj Mittal, Rohit and Bandini, for choosing me to give a speech on this memorable day. So on this day, I would like to say that our train is already running 1 hour late. So I will not speak too much about Mr. Raj and projects and everything, because whatever has been covered till now, 1960 to 1990, 30 years of Mahindra Raj Consultants Private Limited has been elaborated by Mr. Vasudev Nori, Mr. Juneja, and Mr. Dogra. They have told you so much about MRC that I think you need a lunch. So that is why I will say you picture abhi baki hai. So we will meet next year, hopefully, to explain about MRC since 1990 to 2020 onwards. So I will say just one word about Mr. Mahindra Raj, that he was an extraordinary, excellent, exemplary engineer to which all of our structural fraternity is proud of. And there is nobody like Mr. Mahindra Raj. Thank you very much.
Thank you, Mr. Maan. Our next speaker is Professor Arun Menon. He will be analyzing Mahindra Raj engineering, looking at one particular structure from 1965, the Sardar Patel Stadium in Ahmedabad. Mr. Menon is a professor of structural engineering at IIT Madras and also holds a first degree in architecture and PhD in earthquake engineering from University of Pavia, Italy. His research interests are in structural aspects of historical constructions, earthquake behavior of historical masonry structures, earthquake-resistant structural masonry, and earthquake-resistant risk assessment. In these areas, he has published about 95 technical articles. He coordinates the activities of the National Center of Safety and Heritage Structures at IIT Madras.
This one, sir? Yes. I can use- Yes. Namaskar and very good afternoon to one and all present here. Let me begin by thanking the organizers of this symposium honoring Mr. Mahendra Raj, the Indian Association of Structural Engineers, and the SVR Foundation. I am grateful and feel humbled to be a part of this first event honoring the legacy of Mr. Mahendra Raj today on his birth anniversary. I've had the fortune of interacting personally with Mr. Mahendra Raj only twice in the last few years. But it is this recent experience in the last year and a half of studying in depth one of Mr. Mahendra Raj's designs, designed along with architect Charles Correa. That was almost like a pilgrimage for us in this project. It gave us very rare insight into what this personality was really made of. So without further ado, please let me move on to the project itself. The topic of the presentation here today is analyzing Mahendra Raj engineering, and the focus is on this particular structure, the Sardar Vallabhbhai Patel Stadium at Ahmedabad. Now, I would like to state a couple of things. This is an effort that was within a project which was supported by the World Monuments Fund and the Getty Foundation and the Ahmedabad Municipal Corporation. So this was a component, the part that you'll be looking at is a component of this larger project. I would also like to acknowledge my co-authors here who worked on this project. S. Krishnachandran, who is a doctoral researcher at IIT Madras, and Professor Amalan K. Sengupta, my colleague in the Structural Engineering Division of the Civil Engineering Department of IIT Madras. So moving on, a little perspective on the period that we're talking of when this structure was designed and constructed, and the context of this project itself, the recent project that I'm talking about. Many of India's finest structures in the post-independence era, there are many of them, the Tagore Memorial Hall in Ahmedabad, Hall of Nations, Pragati Maidan, the Hindon River Mills, Ghaziabad. Many of these have been designed by Mr. Mahendra Raj in collaboration with the best architects of modern India, Charles Correa, Raj Rewal, B.V. Doshi, Le Corbusier, Kuldeep Singh, and others. Particularly the structures designed by Charles Correa and Mr. Mahendra Raj. They're distinguished due to the complex and elegant geometric forms, which had robust structural configuration. To name a few, this one, the Sardar Vallabhbhai Patel Stadium at Ahmedabad, the Hindustan Lever Pavilion in Pragati Maidan. And what we today probably don't realize is the complexity in constructing these forms is definitely much more considering the prevailing economic situation in India, in post-independence India, and the limitation in skilled human resources, the scalability of that particular requirement. As far as this project is concerned, what I'm going to be talking about today is more of a structural appraisal. In 2020, this particular structure, the Sardar Vallabhbhai Patel Stadium, was included in the World Monuments Watch, being a structure with significant historical significance and contemporary social impact. The Getty Conservation Institute of the Getty Foundation in the United States of America included this structure among 13 significant 20th century buildings. And this structure received a grant, a team received a grant under the Keeping It Modern grant for conserving modern architecture. Now, as you all know, this structure was built in Ahmedabad, a region that is significantly affected by earthquakes as late as 2001, with the Bhuj earthquake. So design and construction of this stadium actually started even before the publication of the first seismic code in India, and before the seismic hazard of the city was formalized. That's something important to keep note of in studying the structure under gravity, wind, and earthquake loads. It's essential to focus on the fundamental load paths which actually ensure the structural integrity of this very unique design. A little introduction to the stadia forms structural forms of stadia is important at this stage. This is one typology of construction where the structure dictates the form in terms of its overall layout. And you really require large clear spans to ensure unobstructed line of sights. And therefore you need long span structures. Now the fact with long span structures is you might have to work with increased depths of section. Use of material in an economic manner can become a challenge. We're talking of a period where country was still not affluent. Now, if you increase section depths, you're talking of increasing dead load significantly, earthquake loads, and of course, there are serviceability constraints of increasing load and looking at long span structures. And therefore, minimizing dead loads is imperative as far as these structures are concerned. However, one has to keep in mind that stability under wind loads can actually get affected. So it's sort of a tricky design by itself. One needs to create a delicate balance by minimizing mass on one hand and maximizing stiffness on the other. In the present day context, if you look at the various stadia that are coming up across the world, you have a spectrum of innovative materials, tensile materials, fabric, extensive use of steel, and so on. Innovation both in materials and structural forms. And of course, we need to understand that today we have very sophisticated, fast structural analysis software as well, the benefit of which didn't exist at that point in time, the 60s and earlier. If you look at the period immediately after independence, even steel was rarely used in stadium roofs. And therefore, this balance, minimizing mass and maximizing stiffness, how could this design balance be achieved elegantly? That was a fundamental question to be answered. The typical forms at that point in time, in terms of the stadia designs, were post and beam structures or goalpost structures or cantilever structures. Now, these cantilever structures are quite advantageous because you need supports only at the exterior edge, and you can get unobstructed sight lines for the viewers, which is beneficial functionally. Now, Pierluigi Nervi, he did incorporate similar structural forms in the early days. The Berta Stadium in Florence, built between 1930 and 1932, and the Olympic Flaminio Stadium in Rome between 1957 and 59 attempted to use such a structural form in the design. And therefore, the option was, the choice was to go with a cost-effective design with long-span cantilevered roof. And there are important aspects that need to be kept in mind as the constraints. The grandstand mainframe and the cantilever roof were to be designed such that the resultant eccentricity on the foundation is minimized and not subjected to uplift forces. So this was one fundamental constraint to be kept in mind. The self-weight of the cantilever, we're talking of a very long cantilever, massive cantilever, to be minimized so that the cantilever moments are not exceedingly high, such that the allowable stresses in the concrete elements are again not exceeded. You can get significantly high concrete stresses if the cantilever itself is quite heavy. And the longitudinal profile of roofs could follow the bending moment profile of the roof. So these three were sort of giving direction to the adopted form in the structure. A little introduction on the final form of the structure, and then we can get into the specifics. The roof of the stadium, the final design, was 23-meter long cantilevered reinforced concrete folded plate structure. And this had at its free end of the cantilever 75 mm thickness and 150 mm at the support. In the folded plate, the depth of the trough, it reduces from 2.75 meters at the support to 0.9 meters at the free end. The cantilevered roof was connected to the supporting mainframe of the grandstand, which was also designed as an RC folded plate system, the depth of which was 5.8 meters at the junction with the roof and 1.5 meters at the base. The mainframe itself was then connected to the seating frame through a ray curbing. So this was essentially the overall structural form. And interestingly, with the foundation, the mainframe and the seating frame were both resting on a combined strip footing, which were then connected to the adjacent frames through plinth beams. So this was the overall structure. Now, the first aspect that I would like to focus on is the innovative use of the RC folded plates as the principal load-bearing element in the structure. You look at the overall structural system, the uniqueness in the structural form lied in achieving the objectives of an innovative use of the RC folded plates, not only for the cantilevered roof, but also for the mainframe. So this was an interesting use of the folded plate reinforced concrete construction. Now, the folded plate, and why the folded plate here? The intrinsic nature of the folded plate system is that it has form-based rigidity and strength through its curvature, and this becomes an economical solution for long spans. Another very useful advantage, and at that time was definitely a constraint, was the construction costs could be kept relatively low because you could have simpler formwork and reuse the formwork. And with limited skilled manpower and mechanization technologies, one of the critical constraints which came into the design at that era was how would you design economically but reliably? Examining the use of this folded plate system, if you have wind pressure from under the roof, these cause uplifting forces on the cantilever roof. So you might want to have a lightweight structure, but the lightweight structure would have insufficient mass to naturally counter the wind-induced load effects. If you were to increase the weight to counteract the first point, then you'll end up increasing the dead weight of the cantilever, which then makes your design more difficult to deal with. What are the alternative approaches? You could stiffen the lightweight structure. You could use hold down mechanisms. This was what was attempted in the Olympic Flaminio Stadium with inclined steel-filled tubes, concrete-filled steel tubes. So this is one possibility. But again, you would have massive compressive loads when the roof is subjected to uplift. So this was, of course, a downside to this option. What about thin shell structures? There were already thin shell structures coming up across the world. Zarzuela's Hippodrome Stadium in Madrid is an example designed by Torroja. But then the cost would shoot up because of the shell structures which would require formwork that's not unique and cannot be reused elsewhere. So this was definitely not going to be an option. So the advantages finally of the folded plate structural form, both in terms of structural stability and construction economy, was that the structural form of the folded plate was relied upon to effectively resist wind-induced uplift forces. The folded plate geometry with staggered reinforcement layout was effective both under wind-induced for wind-induced bending and uplift forces, not only under wind, the uplift forces due to wind, but the bending under gravity as well. So this worked out to be the configuration to be adopted. What's interesting to note is at this stage of experimentation, the American Concrete Institute's building code had a very brief commentary of the complexities of the design and construction of such systems. And clauses for design and construction of shells and folded plates actually came out only in 1971. So we're talking of a period when design guidelines were not available in such constructions. Another important aspect of the design is the inclination or the incline of the main frame. Now, the inclination of the main frame was actually chosen very carefully to reduce the moments transferred to the foundation. And that's instructive as a structural engineering exercise to really see the effect of this incline. So if one were to look at a 2D model of the main frame with the incline and study the same without the incline and examine the bending moment diagram for dead loads and live loads and also look at the axial force diagram, it becomes quite clear that the choice of the incline and the angle of the incline is what minimizes eccentricity of the resultant forces at the foundation and can help in economizing the design. It's interesting to read this narrative of this design. The incline allows the center of gravity of the superimposed loads on the cantilever folded plates to pass through the combined strip footing. This way, large cantilever moment on the frame is dissipated by the time it reaches the foundations, making each part of the structure work with the other in a fine balance. So there's this poetry in the structural design that the incline is able to allow. So this is again a sketch, the drawing of the foundation, the combined foundation, combined strip footing of the main frame and the seating frame. Now, if you were to look at the stability of the structural form under wind loads, the earlier case was purely under dead loads and live loads. We're looking at, in this slide, under wind loads, what is the role of the incline of the main frame? Here you see the bending moment diagram and the axial force diagram with the wind load and the dead loads. This has been designed such that the forces generated by wind do not end up causing uplift at the base of the structure. The dead loads of the structure effectively counteract uplift forces in the foundation due to wind. So you get a very efficient design satisfying the structural requirements. It was instructive to see if one were to use the earthquake input that we use for Ahmedabad seismic zone 3 today for this sort of a structure, what is the sort of response expected of this structure. Now, vertical seismic loads become critical here in large span cantilevered roof structure, since there is significant mass that is acting at the roof level. So one has to pay attention to the vertical seismic loads. And it's again interesting to see that in this form, the final structural design, the maximum and the minimum bearing pressure for the foundation still causes no uplift. The horizontal and seismic loads for the different cases with uplift and wind acting downwards. If one were to examine these, you can see that it works well even for the earthquake forces, because lateral force design has been considered, and the robustness of form, structural form, is what is allowing such a scenario of no uplift to be achieved in the foundation and the form that's designed. Another aspect that I would like to focus on is this very interesting tie beam that's sitting in the structure. And it was very instructive to examine what is the role of this tie beam. And since the purpose of the structural appraisal on one side was to look at the genius of the design, it was also useful for us to arrive at necessary rehabilitation interventions on this structure, which is more than 50 years old now. So what should be done, what should not be done in the structure was to come out from the study for Ahmedabad Municipal Corporation to then carry out necessary interventions over time. Now, we looked at this tie beam in the main frame, and I'm talking about this tie beam sitting here. The primary role, as conceived, it basically connects the inclined legs, and it reduces the effective length of this of the main frame. By reducing the effective length of the main frame, it basically minimizes effects of localized buckling, shell buckling in the structure of the main frame. But it's also actually providing a very interesting redundant load path. And when you read narratives on the work of Mr. Mahendra Raj, it's always about first understanding that you need to have this robust load path, and once that is achievable, the detailing follows. So this has provided, the tie beams have provided a critical redundant load path, and the effect of it is that it minimizes the flexural moments that get transferred to the footing. And how does that actually happen? So if you look at this figure here, the primary load path, which is shown by the red arrows, it consists of the resisting applied moments through tension and compression couple on the main frame and the seating frame. So this is the seating frame, that's the main frame. You have the tension compression couple that resists the applied moments, and that's one mechanism. But then if you look at the blue arrows, there's a secondary load path, and that secondary load path actually helps the system further. It consists of a couple now formed due to the horizontal reactions. The blue arrows here, it's the horizontal reactions induced at the base of the main frame and at the level of the tie. So base of the main frame and the level of the tie, you have another couple caused by the horizontal reactions, and this further helps in minimizing the moments going on to the footing. So provision of the secondary load path reduces the tensile force acting on the main frame because of the applied overturning moment. This was studied. The bending moment under the earthquake loads was considered in different scenarios. The first scenario where both the tie beam and the main frame seating, the tie beam is present and the main frame to the seating frame joint is uncracked. We looked at the bending moment demands. In a second scenario, we looked at the tie beam in an uncracked condition, but the joint between the main frame and the seating frame being cracked. And a third case where both the tie beam and the main frame seating frame are cracked, meaning the restraints from those are really not available. What we did see from the analysis is that there is an increase in the compressive stresses, 40% increase in the compressive stresses, and 150% increase in the tensile stresses at the base of the main frame if the tie beam is cracked. And therefore, large flexural moment can be transferred to the footing once the tie beam is unable to provide the necessary restraint. So that by removing the tie beam from the analysis, we could actually see the impact of introducing that in the overall conceptualization of the structural design. The presence of the tie beam, the moment transferred to the foundation reduced by about 2.5 times if there is an active uncracked tie beam. So these are also aspects that gave us feeders into what should we be focusing on in terms of the rehabilitation of the structure. Another interesting aspect of the tie beam, the role that it plays, is through a shell-based model that we were able to see, is how this tie beam actually assists in minimizing localized shell buckling effects in the mainframe. And finally, we did, of course, look at a more detailed model and looked at a seismic analysis of this to understand what sort of failure mechanisms are to be expected in this form, and capacity curve, which compares a capacity curve approach where the capacity, the seismic capacity of the structure is then compared to the seismic demand is adopted. And here we see that the blue lines that you see there are really the capacity curves of the structure. The capacity curves resemble a rocking system with limited ductility. And the principal failure mode of this sort of a system is actually overturning with respect to the base. And we do see that while the system is adequate in terms of its design and existing conditions, the stability for seismic loads actually comes through the geometric proportioning, that it's a form that is dictating good earthquake behavior. And additional stability and redundancy is coming in the form of the tie beams that are provided. One last aspect before I close is a very insightful aspect that we came across when looking at this design during the construction phase, which was non-uniform deflections at the ends of the folded plates, which could actually create a serviceability issue once the construction is completed and attention was not paid. So what happens here, this actually shows you a very astute engineering skills applied at the erection stage. You have the folded plate system, which requires very precise planning for removal of the formwork. One has to be extremely careful in that stage. And the notes of the drawings, the structural drawings, give us an insight into how this was so carefully planned. And this is something that has later gone into the ACI codes, the American Concrete Institute code. So, these were experimental grounds. What was actually done was the deflections were calculated based on flexural tests on field cured specimens of concrete to avoid stability and deflection problems during the formwork removal. So this was based on field data. The deflection would be checked based on the test results on the flexure tests on concrete. And after casting of one segment of the cantilevered roof, deflections at the tip of the cantilever were equalized using mechanical systems, applying jacking force at the different folds, so that eventually you have something that is perfect in terms of its construction and also doesn't leave gaps which can lead to further serviceability issues. So this was another aspect that really is very instructive in the way the structure was designed and executed. To conclude, I would like to say that the structural layout of the stadium was a careful balance of structural mass and stiffness. And every aspect of the design really reinforced that. The folded plates, they act as the principal structural elements, and the increased cantilever span was achieved without increased section sizes. The self-weight of the cantilever and the main frame were considerably reduced with this approach, thereby reducing the support moments at the exterior support. This also achieves the objective of maximizing the stiffness of the system. So when I started, I was mentioning, It's a fine balance between reducing mass and maximizing stiffness, and the design really stands for that. An intelligent choice of the inclination of the main leg, the main frame legs, reduces the moment transferred to the base of the structure. And providing tie beams close to the base of the main frame provided an additional redundancy to resist lateral loads, while it also reduces effects of local shell buckling in the main frame folded plate legs. This has been a very instructive exercise for us at IIT Madras, and I would like to conclude by saying that the structural design and construction of the Sardar Vallabhbhai Patel Stadium at Ahmedabad can be regarded as a rare instance of amalgamation of engineering excellence and remarkable architectural design coming together. Thank you.
Thank you, Mr. Menon. We now thank you, Mr. Menon, and our speakers for this session. We now break for lunch and will recommence at 2:15 sharp. Thank you.
Welcome back. Our next panel brings out another aspect of Mr. Mahendra's contribution made to the engineering fraternity through the several professional engineering associations he fostered and led alongside his professional practice. This panel also focuses on an issue he worked on for over 30 years and is surprisingly still an unfulfilled dream, the pending enactment of the Engineers Bill. The engineering profession does not have statutory recognition and is not backed by an act of the parliament. Regulatory mechanism of engineering is a pending issue in our country despite being one of the most sought after professions. I invite all our panelists to come on the stage with Mr. Manoj Mittal, who will moderate this session as a conversation. Our first panelist is Professor Mahesh Tandon. Professor Mahesh Tandon, Managing Director, Tandon Consultants Private Limited, and guest professor at IIT Gandhinagar, is an international expert in the field of structural engineering. Many of the structures designed by Professor Tandon have been widely acclaimed and have received recognition in India as well as internationally. He has accreditation of International Professional Engineer. Recently, he was given the Distinguished Alumnus Award by IIT Roorkee. Our next panelist is Dr. Uddesh Kohli, Chairman, ECI. Dr. Uddesh Kohli, BE Honors, MBA, and PhD in Economics, is presently the Chairman Emeritus of Construction Industry Development Council, Chairman of Construction Industry Arbitration Council, and Engineering Council of India. He is also Senior Advisor in Global Compact Office of UN Secretary General, promoting this program in India. Our last panelist is Mr. Sudhir Dhawan. Mr. Dhawan was a past president of CAAI, an engineer from IIT Delhi, and an MBA from Faculty of Management Studies, Delhi University. Mr. Sudhir Dhawan has an experience of more than 45 years in engineering and management. His wide experience covers engineering consultancy for infrastructure, railways, metro, rails, chemicals and petrochemicals, gas pipelines, thermal and hydropower projects.
Good afternoon. Welcome back after lunch. So I hope now you are ready to concentrate on this very important aspect and contribution of Mr. Mahendra Raj to various professional engineering associations. Because since morning, we are listening about Mr. Mahendra's contribution to the profession, his works and his life. So now we will focus on his contribution to the professional associations. As some of you may not be knowing actually that he was very active in various professional activities, and he was instrumental in the formation and the running of the Association of Consulting Engineers. I do not know how many of you know the name of this association. Actually, he was the president of this association from 1983 to 1996. And thereafter, he was also involved with the CEAI, Consulting Engineers Association of India. He was also instrumental in the formation of Engineering Council of India, and he was the vice chairman of Engineering Council of India. Then, as I mentioned earlier, also, as you know, that he is a founder president of Indian Association of Structural Engineers, which is primarily the body of structural engineers. So he was involved in so many professional associations. He nurtured them, he contributed them, he mentored them. And so, and he always believed that there's a need of a regulatory mechanism for engineers in India. So throughout his life, he was fighting for the engineers bill. But somehow we do not have engineers bill as yet. So today in this panel, as you have seen the introduction, we have Professor Mahesh Tandon. We have Professor Dr. Uddesh Kohli, who is the chairman, Indian Council of India, and Mr. Dhawan, who is past president of CEI. So we would like to understand his contribution, the status of the engineers bill and the problems with the engineers bill and the way forward for them. I will like to start Mr. Dhawan actually. Mr. Dhawan, I think you were part of the Association of Consulting Engineers also, and you were also the president of CEI. So can you tell us the contribution of Mr. Mahendra Raj in the ACE and the CEI? And also, I learned that CEI also published a CEI story. So can you also tell us something about that?
Thank you, everybody, for and especially IAS that we inviting me here. I'll tell you a little story. In 95 October, I was sitting in my office and there was no mobile phone, of course. Mr. Oberol came and he said he wants to meet me. I said, okay. So he came and said that I am from ACE, Association of Consulting Engineers. And that time I was president of NACE, National Association of Consulting Engineers. And he said that Mr. Mahendra Raj has sent me here and he wants whether ACE and NACE can merge and form a new association. I have a broad mind, so I immediately agreed. And I said, why not? Let's form one association. Why two associations of consulting engineers? So that was the first time I started coming close to Mr. Mahendra Raj. I had heard about him, but I never interacted with him that time, before that time. So in 96, we formed the new CEI, and I see the vision of Mr. Mahendra Raj that he decided to form one large association of consulting engineers rather than two associations doing similar work and having conflicting performances on each of those. So, Mr. Mittal, the good part is that the two were merged very amicably, and we formed one association of Consulting Engineers Association of India. And I also knew that if we form this association, I won't be the president because Mr. Mahendra Raj has a big stature. I was nobody at that time. And I said, but for the sake of profession, we should have one association, and we formed CEI. And this is how my relationship with Mr. Raj started. And it grew on the following years in a big way.
So what was the contribution of Mr. Mahendra Raj then in the CEI?
CEI, he was the main person to start with. And then he had many ideas. He was a mentor. Then when I became CI president, I made him chairman emeritus. I said, you are the guiding factor. Now, you know, he is able to take up tasks on himself. And he announced in one of the meetings that he will try to publish a book about associations. And that's how all ACE, NACE, and CI, they should be consolidated book. And I was involved in that at a later stage, but he was the one who started with Mr. Ghosh, who is also no more, and Dr. Chatterjee. And we formed and CI story was published. And this is the one I showed you here. This is the consolidated book on CI, which has ACE, NACE, and CI. So this is again, he spent a lot of time, and on top of that, he had a lot of photographs and information, and Nirmala was always available to dig it out from somewhere and bring it and show it to us. And I don't know how many man hours I spent in his office doing this book. And it has come out very well, and it's available in CEI. I have brought one copy, but anybody who's interested, we can send that copy.
Yeah, thank you, Mr. Dhawan, for giving the insight into how Mr. Mahendra has contributed to the amalgamation of two associations. Then, interestingly, after becoming the formation of CEI, then ISTRUCT was formed in 2002. I think primarily for the structural engineers. I think many of the people in CEI say, why you need to have a separate association? Why not amalgamate ISTRUCT also with the CEI? And why it doesn't happen? Why this was formed? Do you have any idea?
I was the one who opposed it. I told Mr. Raj that why are you forming another association? And my mind, the primary reason could have been Mr. Abrol, because Mr. Abrol was free. I don't know whether it is true or not, but this was my thinking. Mr. Abrol was free. In CI, there were many other people who were working, and there was some problem with the staff between him and other people. So he was free. And then he formed IS30. I was not happy personally. I said, we are again splitting the associations. And interestingly, when I became CI president, I invited Professor Mahesh Tandon to also join. He was the president of IS30. And I said, Professor Tandon, let's merge the two associations and you become the president. I won't be president. You become the president and we have one, we have one association. But history is history. So now there are two associations.
Okay. So I think there is one difference also, because CEI is a consulting engineers association. Basically, this is association of consulting engineers, while IS30 is basically the association of structural engineers, whether they are into consulting or not. I think many of the structural engineers are not into consulting, but still they are member of the IS30. But if we merge with the CEI, probably they will not be able to become the member of the CEI. Probably, I do not know. This may be the reason.
Let's not go into that, Manoj. Let history be history. So there are two associations.
Okay, right. So, Mr. Udesh Kohli, as I understand, Mr. Raj was very close to you, and he has a very long association with you, and he was also associated with you the formation of the Indian Council of India. And I believe that Indian Council of India was formed primarily for the engineers bill, I believe so. So can you throw the light of the contribution of Mr. Mahendra Raj in the formation of the ECI and the journey with Mr. Mahendra Raj along?
Well, I will start by paying my personal tribute to Mr. Mahendra Raj. He has been a mentor, guide, and a friend who bestowed a lot of affection. I had more than 20 years association with him. Mr. Mahendra Raj was not only instrumental in setting up of CEI, but also CDC, Consultancy Development Center,
Yes.
and also Engineering Council of India. In fact, he was one of the signatories, if I'm correct, in the setting up of the CDC. I knew him when I became the chairman of the CDC, and very close association, and his lot of guidance and help was there in running of the CDC.
He was the vice chairman of CDC also, I think.
Sorry?
He was the vice chairman of CDC also.
Yeah, he was vice chairman there for some time, and then also he was vice chairman of ECI also.
ECI also. And many of you may not be knowing the CDC. CDC is a consultancy development center.
Yes.
And it used to have their office in India Habitat Center. Yeah. And before COVID, we used to have our monthly lectures in their office itself.
Yes, that's true. Okay, then now coming to the ECI, in fact, Mr. Mahendra Raj played a very key role in setting up of the ECI. At that time, the idea was that there are many associations of engineers, subject-wise also, mechanical, civil, architecture, and so on, and institutional engineers, of course, was the main body with multidiscipline divisions. And the idea was, can we have one body which represents the entire engineering profession as an umbrella body? And that's how the idea of ECI was born. Mr. Mahendra Raj, in fact, he was very instrumental in drafting the constitution also. Institutional engineers also joined hand. And another person who played a key role was Mr. K.C. Pant, who was then deputy chairman of Planning Commission, and he was also an engineer. Initial meetings were held in his office, where he invited all the associations, and he sort of impressed upon them the need of for getting together and forming one umbrella body. Anyway, after all that was agreed, and ECI was born in April 2002 in the institutional engineers. And they gave us our office also initially. They were also members of this. So all bodies were members. Later on, when the issue came about engineers bill, etc., and then institutional engineers walked away because their contention has been that since IEI has been formed through a royal charter, There's no need to have another legal body. ECI was formed basically also to serve as at some stage a statutory body. We went to the government also to get the approval. Anyway, then after ECI, one of the main job being this task being the engineers bill, drafted the engineers bill. Mr. Mahendra Raj and myself and several others, we all drafted the engineers bill. That was approved by ECI's board and was sent to the government. If I remember, it was somewhere in 2003 or 4. Mr. Mahendra Raj incidentally has been working for almost about 2 decades before also on this one. It's not the first time he had been, but here he thought is a body which can take it through. Well, there have been several meetings within the government. I remember having met most of the ministers that time, starting with Murli Manor Joshi, Smriti Irani, Kapil Sibal. I mean, several, almost half a dozen ministers we met and sort of requested them, and the draft was discussed and so on. And the committee, etc., was also formed. It was almost going through in 2011. The Ministry of, first of all, it took almost 2 years to decide which is the nodal ministry. And in the government, then I met the cabinet secretary, Mr. B.K. Chaturvedi was a good personal friend, and he got it through. It has to come in the rules of business, which are promulgated by President of India. So it came that is part of the Ministry of HRD. Then HRD Ministry took it up. So 2011, February, I still remember the date, there was a meeting taken by Special Secretary Ministry of Education, Ministry of HRD, now Education, where it was inter-minister meeting. He invited most of the concerned ministries, and among the associations, ECI, IEI, and CEI. They were all there. And there it was agreed finally. And there's a draft which was circulated and amended and so on. The Ministry of HRD finally agreed. And in that meeting was agreed that yes, there's a draft bill, this should be taken through. Formally, again, they sent to ministries, got the comments, and then a cabinet note was also prepared. We have got to that stage where a cabinet note was prepared. Well, after that, well, my information is that institutional engineers, although they were part of the meeting, they again went to ministry and saying that IEI has been established through a royal charter. Why should we have another body? That is why, that's where it got started again. Anyway, there's a long journey. After that, Mr. Maheshwaran also tried, and several others tried, and I think it got revived.
But before you go forward, I think there was some PIL also regarding engineers bill. There was some.
Yeah, they were separate. I'm not going to that. They were in the court also, but in one of the court, the scene was, it said very clearly that engineering is not governed by any law. Law. It came in that one, and first there should be law and so on from that. So those were there, but I thought that's not so relevant now. But just then we had instituted the Eminent Engineers Award also. And the first Eminent Engineer Award 2012 was given to the Metro Man, Mr. Sridharan. Mr. Sridharan, he was also in touch with him, and Mr. Sridharan wrote a letter. Yeah, another person who tried to help us was Suresh Prabhu. He was not the education minister. He was at that time railway minister. I met him, and he wrote letters also to the HRD minister. Mr. Sridharan wrote to Prime Minister, and then this thing got revived again. And with that, the letter was sent from PMO to HRD, and HRD to AICT, and AICT constituted a committee. Then that committee drafted another bill, another draft, taking into account previous drafts also. They held a meeting, came to us, we gave comments. Mr. Mahendra Raj went through each, I must say, each clause very minutely, and then we gave detailed comment. Then the AICT came with a revised draft. The revised draft was circulated. Then again, we had some comments on that. I met the education secretary also at that time, the higher education secretary. And we said that we have few comments, but still at least let it go through, because 90% things were okay in that one. Then came another setback. The setback was that the government decided to set up Higher Education Commission and merge the UGC and AICT in that one. That was, I think, 4 or 5 years back or something. And then the ministry said, okay, now let it wait. Let the Higher Education Commission be set up. And then that commission will then take up whether there should be statutory body or not. So this is where the matter rests right now. Somehow it could, this dream of Mr. Mahendra Raj could not be fulfilled during his lifetime.
Yeah, so, okay. So, Professor Tandon, I want to know, first of all, I want to know why we need engineers bill actually.
But
Can you
before
tell
I
me?
come to that, can I just comment on what Udesh has
Yeah,
just been
sure.
saying? Since this is supposed to be a conversation,
Yes.
I think now looking back, it was the dissensions amongst engineers themselves, which was the cause of this engineers bill never fructifying. I don't know what the views of other people are, but if we had, the same kind of cohesiveness and large-heartedness, which we should have with our peers, the engineers bill would have come long ago. But that was not there, and I hope that in the future we will not have this differences where egos come in the way of reaching a goal, which is in this case the engineers bill. Anyway, enough about that. Unless you want to.
Yeah, I just want to know, see, why we need actually engineers bill? Just
Yes.
can you just tell me the few things? I know many engineers, they say we do not need, for example, computer science engineers, electronics engineers, there's so many branches of disciplines of engineers, they are not much bothered about this engineers bill. I think only the civil engineers, the structural engineers, and although they are more concerned with this kind of engineers act actually. So why we are focusing on engineers bill, which is comprehensive, why we are not focusing only on the civil engineers act or structural engineers act? Probably that will be easier to bring actually. Tandon Saab, and then I think Dhawan Saab. Yeah, okay.
Okay.
Yeah.
I think to go by the right sequence, I would like to just read out whatever I have drafted the whole of last night, so that I don't meander while I'm talking.
Sure.
Since I knew that I had to talk about the engineers bill, Mr. Raj Mahendra's unfulfilled dream and the way forward. So whatever I have drafted, I would like to read it to you. Oh, sorry. And actually it gives me pleasure to talk about his unfulfilled dreams, because in the process, you will understand one of his basic characteristics, which was his tenacity. He never gave up anything halfway just because he did not succeed here or he did not succeed the next time. He was still at it. That is something which I think this Mr. Mahendra Raj was his fantastic characteristics, and I think that is what has not only helped him in his professional work, but also in his dealings with people and with associations, etc. So you mentioned about why it is necessary to have an engineer's bill. Statutory recognition of the profession of engineering and registration of engineers have been overlooked by our country for a very long time. It was in 1970 that the Planning Commission set up the Barve Committee, who first identified the need for regulation of the engineering profession and for its proper growth and development in the country. So that is basically the reason why you need an engineer's bill. The other things are matter of detail. The Barve Committee concluded that without statutory recognition backed by an act of parliament, this would not be possible. Till today, the profession of engineering does not have legal status, and that remained one of the unfulfilled dreams of Mr. Raj. Without statutory registration of engineers, the government does not fulfill or discharge its responsibility to safeguard society from the hazards of unsafe an improperly engineered and maintained built environment. So it's
So
a
basically
two-way.
you need Engineers Act for the professionals involved in the built environment.
Built environment is basically that. The other people, like for example, when we had this engineers bill, whatever was floated by AICTE and all that, they concentrated on even you should have people from the academics, for example. And academics, I told them in the meeting that you can have people from academics who have a some connection with the professional engineering. If they are only teaching, they don't need to become members of this. And this was supposed to be, engineer's bill is supposed to be a professional engineer's bill. The professional part of it, somehow people are not stressing, but that is what it is supposed to be. Even in Gujarat, when they had that, it is the professional engineer's bill. That is people who are practicing, not people who are teaching only or something like that. They can have some other bill to regulate it. We have, the total number of engineers in our country are equal to all the professionals in all the professions that you can think of. There are more engineers than that we have. But they have, like for example, you have a chartered accountants bill, who have a fraction of our numbers, but they have a professional chartered accountants bill. You have an architect's bill, who are also a small percentage of our population of engineers.
Yeah, that is true.
But-
I'm not saying we should not have. What I'm saying is, just I wanted to know, if you can answer, why we need a Engineers Act for a computer science engineer or a IT engineer when we know that they are doing very well and they are getting good salaries. The sector is booming actually. Then why, and they are not directly related to the public safety and all those things.
Yes.
So basically, should not we concentrate on the Civil and Structural Engineering Act? Probably that will be easier to get. This is my view. Then let's see. Yeah, I think both of them want to say something on that.
Okay. Please.
Can I?
Please. Of course, I was trying to go through a little bit of history, because if you want to talk about his unfulfilled dream, you must know what his dream was.
His dream was.
So it was, we are talking about 1970 when this Barve committee was formed by the Planning Commission. 20 years later, 1990, after the Barve committee report, it was Mr. Mahendra Raj who took up the cause of pursuing the engineer's bill. This 20 years, Barve committee submitted its report, recommendations and all that. It was perhaps lying in some shelf collecting dust. But it goes to Mr. Mahendra Raj's credit to have revived it. And since that time, that was 1990 or so, he has always been in the forefront. There have been so many attempts by so many associations, organizations to somehow make it come awake. But the leader was always Mr. Mahendra Raj, who was guiding and who was taking active participation in it. And then finally, I'll cut short the story because some of it has already been told very ably by Udesh. It was 20 years later that in response to one of our several sort of proposals that we had made to various ministries, including the MHRD, which happened to be the nodal ministry for us. Why it was there, I think that was a big mistake. And I wish I was there at that time. And I would never have agreed to it. And I don't know whether Mr. Raj even knew that it will go to it and that we have a say in the matter. What does higher education have to do with the the profession of practicing engineers? Nothing. It is so it was a mistake, and I will tell you what the latest thing is, so that you know that what the mistake was. In response to many of the proposals and entreaties and letters that we wrote, and of course, I must not forget here the name of Mr. Sridharan, who helped a lot in the matter. We got a letter back suddenly one day from the MHRD, which by now was called the Education Ministry. And this I am talking about 1 year ago exactly, 25th November 2021. And I am just telling you one extract of that. Education, the new education policy 2020, this is what they have written, which is now in force. The new education policy envisages setting up of Higher Education Commission of India. So the Higher Education Commission of India is, the acronym is HECI, of which National Higher Education Regulatory Council, that means the National NHERC, National Higher Education Regulatory Council, will be a vertical in that whole commission that I talked about. This regulatory council will function as a common single point regulator for the higher education sector, including teacher education, but excluding medical and legal education. I think they didn't want to mess with them, if I may call it that, thus eliminating the duplication and disjunction of regulatory efforts by the multiple regulatory agencies that exist at the current time. It will require a relook and repealing of some of the existing acts. So, I mean, here they only talked about the legal and medical. What about chartered accountants? What about architects? I think all of them are going to be reviewed, and we don't know what will happen finally. And they are talking about restructuring them. I mean, this is the type of thing that they are talking about. It was accordingly decided that the Higher Education Commission of India and the National Higher Education Regulatory Council should be first formed. It is not even formed yet. It has to go through it has to be formed by an act of parliament. And they are talking about
So it basically says that this act doesn't have the priority of the government in any way. So now then Mr. Dhawan, can you tell then Dr. Deshkoli?
You want to finish?
Yeah. Well, anyway, I think that what I'd like to say, since we are going to talk, it is stuck, because now there is no use going here and there. What we have to do is what they have said, all concerns raised regarding the regulation of the profession of engineering through the proposed bill, which they know what it is, should be addressed by the proposed structure of Higher Education Council of India and the National Higher Education Regulatory Commission. So basically, it means that you are now not in that route of AICTE and this and that. We don't know whether even they will exist or not. And they are already thinking of replacing the University Grants Commission, for example, and putting it in this. So it's so our thing where we have to go is this. My basic fundamental question was.
I will answer your question, Manoj, that why do we need the engineers bill or any regulation? All engineers don't need it. I fully agree with you. Electronics and all we are saying. This is only required by consulting engineers. But consulting engineers of all disciplines. be it civil or mechanical or electrical, pipeline or refineries or power plants. Why we need this bill is that there's a mushroom of consultants who are in place and they are saying they can design anything and do anything. And that's why there are some failures of structures and other things. So there has to be a regulation. Second point is that as per the WTO Act, India cannot stop any foreign company to come and work here in the engineering profession because India's regulations have to follow with them also. We cannot have special regulations for them and different ones for Indians. So if we have a requirement of regulation through which engineers doing consulting engineering have to be registered, so then when a foreign company or foreign engineer wants to come and work here, they need to be registered first. And as we do, I mean, if we have to work in UK or USA, we have to go and register ourselves and then only we can work. So that part is not there in due to WTO. We cannot stop them. And you know, there is a number of foreign consultants who are working here. So consulting engineers need a regulation and not every engineer. So this is the simple answer to your question.
I think your question very specific, and I'll give very specific answer.
Yeah.
Sum up what he has said and he has said. I think there are three reasons why you need that. Number one is the recognition. Recognition of professional engineers in the country, just like doctors and lawyers and so on. And once they are registered under this statute, then they can practice anywhere in the country, in any organization. They need not register with municipal bodies or departments and so on. One registration under the Act is enough. And that shows that they are competent people. So that for society also, it's a recognition of a competent engineers over there, number one. Number two, in the absence of any act here, any regulatory body, anybody from anywhere in the world can come and practice here. No one can stop it. Unlike chartered accountant, lawyers, or doctors from the country, they cannot work here unless the regulatory body here, a statutory body here, gives them the permission. They register with that only. So we have big handicap. Number three, what he said, I'll make it very clear. Our registered engineer, once they are registered by statutory body, they can work anywhere in other country. Their competence will be recognized, provided we have mutual agreements. Automatically, they cannot work. But then we have bilateral treaties, like with Singapore. And Singapore, I remember I had joined, and they said, once you have a registration here, you can we'll allow them to work here. So we can have mutual agreement, provided we have a statutory body to register it. So our people can work anywhere in the world then. So that's the third. And let me add one more small thing, is that once we found that this was not going through this thing, then Mr. Mahendra and many of us and the ECI in the board, we decided that we start voluntary registration. In fact, Ministry of Education, once the secretary told us, why don't you start on voluntary basis? Why do you look at the government for everything? Why don't you start it? So I said institutional engineers are doing it. ECI with all the umbrella body will do it. So in November 2015, we launched the registration. Mr. Suresh Prabhu was chief guest, award minister at that time. And we launched it in his presence. And after that, we set up a body called Board of Registration of Professions, BRPE. Mr. Mahendra took over as the chairman of that. And we have registered by now about 3,000, 4,000 professional here. But let me also add credit to Mr. Mahendra. Till about 15 days before his death, he was still the chairman before he resigned, about 15 days before that. And he was looking into the candidates and their profile and all that, whether they are competent or not, because every candidate has to be screened and scrutinized. Until about 15 days, he was working on that. Yeah. It's a great.
Yeah. So what is the way forward now? Basically, now, as Professor Tandon was saying, it is stuck now. Basically, they say some commission will be formed, and then if it is so important, then how we should proceed further? Because as you are saying that ECI registering professional engineers, so on a voluntary basis, yeah, same is a institution of engineers, and similarly any other organization can also do it. Probably, I don't know. So ultimately, unless until we have some regulation, some act of parliament, this problem will not solve actually. So what is the way forward in your opinion?
I think according to me, the way forward is to pick up the baton from where Mr. Mahendra Raj left it, which means that these are all setbacks. They have been coming for the last, from 1970, we've had only setbacks in this. And Mr. Mahendra Raj had the courage and the patience to still try and see whether we can get it through. I think that we have to continue that same zeal, with the same zeal, to see whether we can get this thing through or not. But we, of course, our aim now has to be somewhere else. Now there is no confusion. The government has sort of formed this new education policy. Is not going to change overnight unless there is a change of government or something like that, or something drastic like that happens. This is going to remain. So the agencies with whom we have to now keep in touch with is this Higher Education Commission of India. Abhi bana nahi hai, but yeah, bana nahi hai, but this is the time to sort of think of all the what is it called? The preparation. Before you go to the Olympics, you have to do 2 months of preparation, right? So that is what we have to do now. That how do we tackle this? We don't have to now go to searching for MPs and all. I don't know whether you recall how many times we have written down who are the engineer MPs who can help, and then meeting them and all that. All that is not required now.
We met ministers also who were engineers, and nobody
Yes.
was able to help. I think, Manoj, the simple answer to your question is PMO. If we can convince PMO, it will work.
No,
Nothing else will work. In India now we have seen, everything works only if it is through PMO. So we have to now convince PMO why engineers bill is required and why it is different than other. Actually, what happened, there was a big setback because of MCI and legal bills. There was a lot of corruption, and within the government they decided no more these bodies, no more regulatory commissions and MCI. MCI was really bad. You must have read in the newspaper how many crores were made and all. And unfortunately, chartered accountants were both regulatory body and they were also examining the students. So they were conducting exam and all. So USA government objected to this, that how a regulatory body is having both the functions. So that also has been changed now. So I think, Manoj, the simple answer is PMO.
no, I think that I'll just tell you the progress made. 1 minute. We have already written to the PMO, not the PMO, the PM. Let me just finish. We have written to the Prime Minister. He has forwarded that to whatever his secretary or joint secretary or whatever. And from whom I have read this thing, but the basic thing is that we have replied to that and said that this Higher Education Regulatory Council and all, whatever you are talking about, that has something to do with education. By all means, you see which colleges should be closed down and which not the that part is a parallel activity that you keep on, and you have to write to the Prime Minister, not the Prime Minister's office anymore. You see, the situation, the politics keeps changing with the change of guard. Now you write straight to the Prime Minister and you get a reply. So
I think that is,
Council of 24.
well, now 30 plus. See, it's what Mahesh has said, that's one line of action. That is approaching the government again and again, and we keep on doing it. A different department. My suggestion is something different. My suggestion is that, and I go by what Secretary of Education said. Why are we looking to the government? Why are we doing the statutory thing every time? The Engineering Council of UK is not a statutory body. It's a voluntary body like we have, and ECI. My feeling is that One answer is that we should have our own voluntary registrations. As we started, we have over 5,000. If we have a big mass of, let's say, 20,000, 30,000 engineers registered, that will give us a big strength to do government. Look here we have got 20,000 registered. Why don't you give recognition now, statutory recognition? My feeling is that these days it's like, like Bhanji going and doing a dharna type of thing. This is something similar, that you have all the big mass. We don't have critical mass, just 4,000-5,000 not a critical mass, 20,000-30,000 critical mass. Then we can go to the government. Here we are, and these are the advantages, and this is our thing. You can statute whichever way you want to do, you can do it.
But there's a problem that institutional engineer also doing.
Both.
Yes, yes.
We have both of them together. I'm not saying there is no competition. Both of us can do together. Why not?
I think
They are doing it, we can also do it.
we can even have different associations giving, this is after all a voluntary basis that you are trying to get a certificate of registration or whatever.
But our ECI certificate is joined with the association. Every certificate, whichever is body is there, it is not only ECI. ECI with structural engineering, ECI with mechanical engineering, ECI with civil engineering. So it's a joint one, but it is one recognized.
Okay, so basically what emerged is that Mr. Mehta's contribution was immense in all the associations, and he contributed a lot in its activities, and he was the force behind the engineers bill actually, which is still pending. And the way forward, which seems from the panelists, is that we should, one way is to again pursue with the government, with the PM or the PMO. And another way, Mr. Udesh Kohli is saying, Dr. Udesh Kohli is saying, the voluntary registration as a professional engineers with the ECI or institutional engineers, when the critical mass is there, then go to the government and then ask them to for the act actually, or give the recognition. Now we have we can take some questions for the panelists. Yes, please. Well, please tell your name and then you can.
Judge whether an engineer is worthy of practicing or not, because that's really important. Just having the bill is not enough. How that comes through is very important. So what is the suggestion of the thought process on that?
Okay, so who would like to take this question?
You see, there are several ways of doing this. One is a good system which is even done by the Institution of Engineers. They also have a professional engineers registration. Now in that, and they even have international professional engineers registration. Now in that, what happens is that it is clear that these are the people who are in the panel, who are not only going to see what your background is and all that. You have to have an interview, online or physical, whatever. I mean, so far it has been online most of the time, and sometimes exam. So all this can be done to assess. It all depends on how but let the thing come first, because there are so many alternatives available for the route which you are saying.
Yes.
So it's well defined.
If you go through the draft engineers bill, still you will find that it was a very good draft actually. And just I wanted to also inform you, related to your question only, that even IS Technology is also starting a new initiative, and we are also starting a certification as accreditation as chartered structural engineer IS Technology, and where we are saying any graduate civil engineer involved in the structural engineering with 5 years of experience can go through this certification. And for that, he has to first go through an interview process for the initial assessment of development assessment through interview process. And then he has to go through a written examination of 5 to 7 hours. Actual problem in different areas. We have developed methodology. So I think very soon we will be launching that certification. So there can be several ways of judging the competence of any individual. So that can come actually. But the ultimate thing is government's intention to bring the act And that is more important. Yeah, so ultimately, see, as they have professional engineers certification, institutional engineers also have, but unless until it has the backing of the government, it will not serve much purpose actually. Similarly, we are also starting it where we know that unless until it's the backing of the government, still it will not serve much purpose. But still, if we have a critical mass and a lot of people are going through this process, probably one day you will get something.
Can I just add one thing? See, in the draft engineer bill, several drafts have been there, but one thing common in the engineers bill is, unlike medical council or bar council, where there's a separate medical council which assesses and conducts exam or whatever it is, and there are state medical council, the engineers bill had provided that the assessment will be done by the professional association of engineers. They will be setting up their body and they'll be licensed by the statutory body to recognize the professional qualification. So assessment was to be done by the professional association, which is very different from medical or bar or dental associations and so on.
And then it will be renewed after some years, after 5 years or something, based on CPD.
Just one thing I want to mention. You see, all these things that we are trying, the separate associations or big association of Udesh, they are trying this. But basically, if you get any kind of a certification like this, it looks good in your biodata. But beyond that, it has got no value. Unless it is backed by the Act of Parliament, then yes, it makes sense. You can say then, if you want a government job in the CPWD, you have to have the certification before you can even be considered. Because that is something which is meaningful. But otherwise, if you just keep collecting these certifications and all that, it has a limited value.
Let me add there also. See, we have simultaneously from ECI, we have been writing and trying with the government departments and so on. Now CPWD in their contracts, they provide that I think it's about 5% of engineers to be employed must be professional engineers, either from ECI or from IEI. Several, Delhi PWD also has done. Several organizations are doing it. We have been approaching them. Several organizations are recognizing the professional engineering certified by any of these two bodies, may not be statutory, but it shows a certain competence level. So it will come. As I said, once we have big mass, this will also come. More and more organizations will recognize. We have written to public undertakings also to specify in their contracts.
But Dr. Udeshkuli, I have a fear that it is a very long drawn process. The long drawn process. Yeah, it is. Any other question here?
Yeah, grateful to you, gentlemen, and congratulations for this event. So I'm Ajay. I'm a waterproofing and rehabilitation consultant with respect to entrap dampness. So my basic thing is that the life of the structures is going down. Can you imagine this life of the structure is 62 years and this auditorium is designed without RCC. So what I would rather suggest, because I've been, closely associated with the IBC and Institute of Engineers, and this issue is coming every now and then. But what I would like to suggest is that, like the gentleman said, that we should, fight for accreditation of engineers. Today, in the post-construction rehabilitation, and what of course, the premier engineering institutions like IIT, don't have any expertise or experience, whereas the structural consultants in your body has ample adequate experience, but they don't have the accreditation. So I think you should first fight for the accreditation. And secondly, like this gentleman said, today, structural consultants are using excess steel, excess cement, to design disaster structures. So there should be a, some mechanism to review every after 3 years, the competence of the structural engineers. And I think you can prove it to the government, you can take it to the government. Yes, we want to form a body with this and we promise you this. Then I think I can promise you this act within 3 years, which has not been given in the last 52 years. So gentlemen, with that, grateful.
No, I think that what you said is absolutely correct. But accreditation by whom is the question that we are trying to debate. Supposing we have so many associations, if we get the accreditation of that, is that enough? And who will recognize it?
And then accreditation will be able to, that's my suggestion. So this is the government which is working. So I think you have to just, I'm a disciple of Professor S.K. also. One of the biggest talent in structural design. I'm his disciple with a purpose. Yes, I want to eliminate structure, infrastructure, there is some in the country. It's a 15 years, I got 3 years, the 5 years have already spent. Yes, sir. So it's just a quarter of me. I asked government for 3 things. One is moisture content maximum level of 14% in the structure. So now they are ready to give it. One is manufacturer guarantee. I asked for air guarantee. So government is not.
Thank you. We will discuss that point later on. There's a question here.
I have one question. What exactly this bill constitutes? What are the broad outlines of the feature of this bill?
I think we can discuss that during the break, because our session is going to be over now.
Okay.
We are already exceeded the limit. And
No, because many of engineers who are participating, they may not be aware of what exactly is this.
So basically this engineers bill which we want to have actually, it will have a definition of a professional engineer, who can be a professional engineer, definitely based on the qualifications, experience and the based of assessment, whatever. So there will be a definition, and one who want to become the professional engineer, he must satisfy those criteria. So this bill will have those criteria, and then there will be a regulatory body who will manage all those things, and who will register and who will give the license or whatever. And then this regulatory body will also do the periodic renewal of the licensing or registration. This will be basically the content of engineers bill, and the draft bill also have similar kind of things basically. Yeah. Yes, it is available on the website, and it is very comprehensive. I think it considers best practices. It's the best practices of the world. Actually, it has been contained in that draft actually. So it's a good draft, but yes. Yeah.
Thank you.
I think just wanted to finish this last part that we had discussion. You see, when you get any kind of a professional certification in whichever part you are in, including India, you have to prove that you are continuously updating your professional competence. So that is what we call CPD, continuous professional development. So even from the Institution of Engineers, when you get either an international professional engineer or just professional engineer, the 2 categories, you still have to go and prove to them that after 5 years or 4 years, I forget how many, what have you done to continue this professional certification that you can practice. So that is a part of the engineer's bill. Whenever whichever agency has it, that will be a part of it.
In ACI, it is 5 years. Even voluntary registration, after 5 years, it is reviewed.
Yeah, even the certification which we want to start now, that is also for 5 years, and it will be reviewed after every 5 years. That will be valid for 5 years only. So that is I think all draft have very good practices in the content. So I think we can close this session now. We have taken a long time. And thank you so much, Professor Tandon, Dr. Udesh Kohli, and Mr. Dhawan for a lively conversation. Thank you so much.
Thank you. Thank you for a very informative discussion to all our panelists. Our last session for the day dwells on Mr. Mahendra Raj's work in context to history, society, and education. Through this very diverse panel, we hope to unpack and consider the relevance of Mr. Raj's work for city at large, for people from different walks of life, for possibilities for future. I take the pleasure to first invite Professor Visalakshi. She will join us online. Professor Visalakshi is an honorary secretary of IS Trukti and is presently working as a professor at Mahindra Equal Central School of Engineering, Mahindra University. Prior to this, she was a founding head of Department of Civil Engineering, Bennett University, Greater Noida. Her research interests lie primarily in developing sustainable building materials, structural health monitoring, corrosion of RC structures, smart materials, and systems. Professor Visalakshi. You may start.
Do I need to start?
Yes, ma'am. You may start now.
Huh?
Yes, ma'am.
Yeah, I thought Miss Tanuja Kanvinde would be the panelist and she would introduce the panel and then I need to speak.
No, it would be later on, ma'am.
Okay, fine. So, do I need to start now?
Yes, ma'am.
Yeah, okay. Am I audible?
Yes.
Okay, thank you. Yeah, good afternoon, everyone. The participants and the delegates present in person and the participants online. Good afternoon. Myself, Visalakshi. Okay, thank you, Haider, for the introduction. So before going for the talk, I would like to first give my thoughts related to the talk. Okay, and first of all, it's a very proud privilege for me to be part of this symposium where we are honoring Mr. Mahendra Raj, a legacy in structural engineering and architecture in India. I'm very thankful to IS Trukti, from where I come from as a honorary secretary, and Mr. Rohit and Vandini for making me a part of this very historic event. Coming to my association with Mr. Raj, it's not very long enough, but very impactful and fruitful. It dates back from 2014, when I was elected as a governing council member of Indian Association of Structural Engineering. Probably I might be the youngest governing council member for that period. And during my association as a governing council member, I was like, it's a dream come true, or I was living my dream when I met Mr. Raj and Professor Tandon, who were the doyens of civil engineering and who I admired and I always looked up to throughout my career. So I was just living my dream when I was associated with these two doyens of structural engineering. And later, when I became the honorary secretary in 2019, the association with Mr. Raj grew more closer, where we were being the members of different committees, where we had interaction related to the day-to-day activities of the association, etc. So that's where my association is with Mr. Raj. And coming to the talk, which I would be briefing about, is how Mr. Mahendra Raj educated the younger lot. In the morning session, I think the first session, if I'm not wrong, Dr. Noori, Mr. Juneja, Professor Dogra, and Mr. Man have shared their personal experiences, how Mr. Mahendra Raj used to educate them and make them learn the intricacies of design. Okay, but now I'm going to present a gist of what the young budding engineers from the Mahendra Raj consultancy and also from other organizations who had the privilege to directly work under Mr. Raj, with whom they had interacted with. I got some insights from them, and I would present a brief takeaways, or you may say the tips, or else you may say the advices which Mr. Mahendra Raj used to give to these younger lot so that they can build their career and excel in their profession. So here are a few takeaways from what I got the insights from these budding engineers. The first thing is the passion which Mr. Raj used to have about the structures, be it from the material point of view, be it from the constructability point of view, the buildability point of view, or from the design point of view. The passion, everyone whom I've spoken to have told me the same thing. The passion he had about the structures. Then the next thing which they told me is he always used to insist the budding engineers to mind the gaps. What I mean by the gaps is the load paths. Okay, he used to say that don't rely on computer software to detect these gaps related to the load paths. It is a job of a structural engineer. And what does he mean by that is all the load parts of the structures, of any structures, are to be tracked, and always the gaps which are there, if it is been identified, has to be closed. Because the reliable load parts are very essential for all structures, and their absence is one of the leading causes of the failures. A complete load path defines how carefully the calculated vertical loads or else the lateral loads are going to find their way to the foundation of your structure. So he always used to emphasize to look at the nature, think about the nature, how it always chooses the path of most resistance, regardless of the design, regardless of the equations. Always it's the stiffer elements which always receive the proportionally more load related to the flexible elements nearby. So we always need to mind the gap. That was the first takeaway which he used to give to the younger budding engineers. The next important thing is related to the stability. Ensure stability. Okay, we might have been trained to size the beams and columns accurately, but the devil is not there. Okay, it is in the details. Structures rarely fail because of beams or columns substantially undersized. More often we see the failure which is due to unanticipated loads, inadequate load paths, inadequate connections, especially the instability, which can take many forms. So stability is essential, not just when the structure is in service, but importantly during the construction phase too. As we might have seen many buildings, especially the steel ones, which have witnessed the failure because of some missing insufficient diagonal braces or lateral braces, bridgings or local stiffness, etc. So always he wanted people to pay attention to the stability of the structure, not just when it is completed, but also during its construction phase. So this was the second most important thing which he always educated the budding engineers. Then the third, which might be a very, very useful tip for the younger engineers, that design first, then compute. You should not make a mistake in understanding computing for engineering. Computing is different and engineering is different. Okay. The reason behind this is that structural engineering softwares cannot think. It is primarily responsibility of a structural engineer to think and design, and then go to the computer softwares for the what you say for refining the design appropriately. Okay, so he always used to insist the budding engineers to deliberately avoid computers until unless they lay out the geometry, until unless they initially fix the sizes of the primarily designed elements manually. He used to always believe, it seems, that if you're not able to roughly design a structure by your hand, you certainly have no business relying on your computer to do so. And I think it's very true. So role of a structural engineering software will come into picture later in order to refine the design as appropriate. And then the next thing he always used to emphasize is on absorbing the knowledge from all quarters of life. So just like being a sponge, be a sponge to absorb the knowledge from wherever it comes from. Because the reason behind this was the fresh engineers who come out of college, as we all know that the college teaches us to build the design, to design the buildings, etc. But it may not teach how to design an economical building, or it may not teach us the entire workflow from the concept design to its visualization and the completion, the entire workflow process. But when these budding engineers join a firm, okay, they have to understand this entire holistic process of this workflow and their role in this multidiscipline design process. So for that, generally a mentoring process is there, which is an important aspect of any workplace training, through which young engineers are actively coached by an experienced engineer around them, and which is also a critical process because it's the most effective way to transfer knowledge from one generation to the other generation. But unfortunately, if the formal mentoring is not always possible, if it is not possible, so he used to always tell the young engineers, it seems, that be proactive, absorb the knowledge like a sponge. Start asking questions of those around you from the moment you walk into the door. While how questions are obviously necessary, the why question usually yield better learning opportunities. And he always wanted people to have a notebook, like an old-fashioned notebook handy, and write down the tips and tricks, whatever they learn. And it might be useful for these young budding engineers also if they have noted down, and it would be useful for them when they play a role of a mentor to their younger lot. So that was a very important and useful tip for the young engineers. And the other most important thing is own your work, whatever you work, own it. So he always encouraged to adopt self-reliant attitude and to own the work which they do. Invest time necessary to be sure of yourself and your designs. Structural engineering is a highly liability profession. Accept that reality and act accordingly. And apart from these takeaways or these advices, okay, there are some general important advices to the young engineers, which might help them to build a career, and I've collated some of them and subjected them as a note to young engineers. The first and the foremost is obtain a construction site experience as early as possible in their career. And the reason for this important advice is, especially this construction site experience is very important for the people who start their career in the design office. Often these people who doesn't have any construction site experience, they often happens that they could not able to visualize the designs, and neither they have an in-depth understanding of the multidisciplinary interfaces because of the fact that they have limited understanding of how the engineering designs are constructed, maintained, and operated. They would review the engineering drawings, all the drawings, etc., but they could not recognize the certain obvious flaws when compared among their peers who had a site experience and who have a better understanding. So it's very important for a young engineer to realize the importance of obtaining a site experience. And also the constructability, operability, maintainability are important aspects of any design process. This enables us to identify and eliminate the flaws in the early phases of the project. And if you have the site experience, I think there are many things which are an added advantage and which come along with that experience. The first thing is that number one is the problem solving and thinking on your feet. As most of the problems which you encounter on the construction sites need to be tackled very urgently. And if at all there are delays encountered due to resolved issues, would likely impact the project baselines and obviously the economics of the project, which nobody wants to. Okay, and the construction environment obviously teaches you to be swift in resolving the issues that arise in day-to-day activities. And during this process, it teaches you to develop practical and efficient solutions which are workable at the site, considering the cost, the schedule impacts, and the technical feasibilities of the solution. So you'll learn all these skills when you are present at the site. Then the second thing which you are able to learn, the important skill is the adaptability. When things go wrong, and when things are not according to your plan, what will you do? So the adaptability is very, very important. For example, when unexpected site conditions are encountered, which necessitate a change in the design, or else unidentified buried services. So these stumbling blocks teaches you a lesson on dealing with the change, dealing with the adaptability. And then the third important skill which you learn is the conflict resolution. So given the number of different stakeholders and the interest on a construction project, conflict is inevitable. So construction is inevitably a high stress and a high pressure environment, and conflicts do rise. So this environment will, if at all you are involved in that environment, you are better. It prepares you to deal with the conflict and develop skill to conflict resolution. And the next important thing, number 6, is the professional ethics and responsibility. So the field engineers are often entrusted to oversee the construction of the design and to confirm the technical performance and confirmation of the quality of the construction. So by doing this role, you'll have to make difficult decisions, especially when the construction doesn't meet the required standards. So acting ethically in difficult situations is an important element of the journey to become a professional engineer. And the next thing is the involvement of different stakeholders, engagement, and the teamwork. As we all know that the construction environment exposes one to different stakeholders with different interests in the project. The client, the engineering, procurement, construction management, the contractor, the stakeholder. These are all the stakeholders of the project. And the project will not be successful unless there is a mutual cooperation between them. So the construction environment teaches these budding engineers the value of a teamwork and the lessons in a stakeholder engagement. And the other important thing which we learn, which may not be taught in the colleges, is the contract management. Commercial matters are usually a blind spot to an engineers because contracts are too wordy documents, right? So the lesson here is very simple. In order to manage a contract, you need to understand the contents and terms of the contract. So understanding it will enable you to better deal the disputes and the contractual claims. And the other thing which we learn is when we have a site exposure is the leadership and the confidence. So since when we work at the site, we have to actively communicate effectively with people with different backgrounds and with different skills. And as a field engineer, you may become a leader representing your organization or your client in some instances, which you are tasked with leading teams. So you develop those confidence and the leadership skills. Then the planning and logistics. It is one of the skills which you develop while working on a construction site, is how to plan the logistics, day-to-day logistics, in order to carry out the day-to-day activities. So construction site, the experience, construction site experience, it's not easy and it's not comfortable, but it's worth it. It's very, very worth it. And lastly, when you are at the construction site, last thing and the most important thing which you can do is the sense of enjoyment, accomplishment, the reward of completing a project. Okay, the sense of enjoyment, it's not tangible at all. When you see a 3D drawing on a paper becomes a tangible physical structure, it's rewarding. That joy is you can't gauge that joy. You can't. It's intangible. So it leaves you a greater level of confidence when you see a physical structure in front of you, which were earlier on a 2D drawing on a paper. So that sense of accomplishment, I think only a civil engineer has that. So in summary, in order to summarize it, the first thing I want to leave to the young engineers is that passion is a powerful tool for success. You need to be passionate about your work, whatever work you do. And the second thing which is very important nowadays is be social and networking. Networking, now the networking has become with the social media platforms, LinkedIn and other platforms, it has become more effective than the previous generations. So be social, do networking with your peers, and be passionate enough. Thank you. Thank you so much to talk about the education and what Mr. Raj used to always emphasize to the young budding engineers. Thank you so much.
Thank you. Thank you, Dr. Visalakshi, ma'am. I now respectfully invite Dr. Narayani Gupta on stage. Dr. Gupta is a retired professor of history. Ms. Gupta has lived 76 years in Delhi, taught history at Indraprasth College and Jamia Millia Islamia, and worked on urban history, particularly that of Delhi. One of the founders of the Conservation Society of Delhi and the member of a Delhi Urban Art Commission, she supervised the listing of the city's heritage buildings and has written books for children on historic architecture.
I can tell your age. Do you want me to stand up from this case here? Yes, ma'am. Yeah, okay. Good afternoon. Thank you very much for inviting a rank outsider to this conference. I'm very privileged, and maybe when now the word engineer means a little more to me than it has done all my life, though one uses it in all manner of senses. You know, he engineered a coup, and even things like construction, reconstructing the pact and so on. It is used so much in political discourse. We never thinks of it as a career and something special. I really felt very nostalgic, but that's not quite the right word, hearing the earlier speakers, because though I have lived over 75 years in Delhi, I met Mahendra Raj only in 2016. And that was when the Hall of Nations crisis had started. So I wish I'd known him earlier, because he obviously was one of those great people who was very inspirational. If one were to make a comparison, the person we are here to honor reminds us of Christopher Wren, who rebuilt London after the Great Fire of London, and in 1666, a plaque in St. Paul's Cathedral, his most spectacular achievement, describes him as the architect of this church and city, and goes on to say, if you seek his monument, look around. Here, monument is used in its old sense, which meant a statue. If you look around New Delhi, you will see many monuments which have Mahendra Raj's name written invisibly across them. When Wren rebuilt London after the Great Fire, Mahendra Raj contributed to the building of New Delhi after the grim days of partition. We all have our favorites. I never tire, personally, of pausing to look at some of the buildings he worked on, though I did not know that at the time. The calm glow of the Baha'i House of Worship, the welcoming building of the British Council, the spare and spacious Alliance Francaise, and the slender upward-looking NDMC office. They make visitors feel taller, and their interiors have atmosphere. He was one of the thousands who made Delhi his home some years after leaving its twin city, Lahore. Delhi itself was really two cities, Shahjahanabad and New Delhi, islands separated by the unbuilt spaces in the 1950s. When he was in the USA, modernism made a dramatic entry into Delhi. Indo-Saracenic, or what is correctly to be understood as Hindu-Islamic, had ended with independence. The ninth Delhi, the infill and the extensions was defined in terms of skylines rather than of space on the ground. The long shadow of Corbusier morphed into that of Rahman, Courier, Rewal, Joseph Stein, Kuldeep Singh. But what made their bold dreams possible, generating a Jugalbandi, was the genius and focused attention of one man, the engineer laureate, Mahendra Raj. Urban art, in inverted commas, had come into its own, but it was not identified by the names of creators. We know that New Delhi was built on the plan of Lutyens. We are reminded of that often enough. Chandigarh on that of Corbusier, but there it ends. Only in the last 15 years, if you think about it, have there been histories of Indian architecture or exhibitions of individual architects. Even more anonymous than architects are the engineers. Now, why, if painters and sculptors actors and musicians, scientists and sportsmen can be known individually. Why not builders? Many scholars in the last half century praised the Nehru Memorial Library as a very congenial working space, but none of them connected the architect Man Singh Rana with the building when he passed away in 2012. Not only are the buildings without signature, there is no other marker. It was not always so. Tolstoy Marg and Deen Dayal Upadhyay Marg, which you probably all know, are actually new names for roads which were originally, and I would ask you to put up your hands to say, do you remember what they were? They were Rouse Avenue, that is Deen Dayal Upadhyay, and Keeling, which was Tolstoy Marg. And who was Rouse and Keeling? They were engineers in Lutjens's team. The canal flowing down Chandni Chowk and in the Lal Killa was called the Ali Mardan Nehar, after the brilliant Persian engineer who had been invited by Shah Jahan to lay out canals in Delhi and Lahore, the city where 3 centuries later Mahendra Raj followed in his footsteps to study not the mathematics that he loved, but engineering. After the days of partition, a sense of optimism set in. From the 1960s, this was reflected in a building boom in terms of institutions and housing estates. These were all over the country, of course, but I shall stick to my last, which is Delhi. The islands of Shahjahanabad and New Delhi were moving closer, and what we refer to as Purani Delhi and Nai Delhi became together Central Delhi. Rural areas to the west, north, south, and east became part of the city on which the cement never sets. Living in Mandi House, which I did in the 1950s and 60s, I watched the empty plots around the Rompua being filled by Sapru House, Rabindra Bhavan, Triveni, Sangeet Bharati, completing a culture circle. Further east was the historic Mathura Road, bordering fields of green peas and the majestic Purana Killa. A grand zoo was planned, skirting the Killa and stretching as far north as the Supreme Court. That was the original plan. But this was too good to be true, and the zoo lost 10,000 square meters to the interests of commerce. My diary for 1955, if you can think back that far, says that the Bhagwandas Road was jammed with parked tongas that had brought people from Shahjahanabad to check on the trade fair. The trade fair in 1972, in the euphoria following the Bangladesh liberation, was had its name changed to Pragati Maidan, sort of distant echoes of Kartavya Path. And it was sketched out for that area and a master plan prepared. The dreams of officials and architects were ambitious, but the state of the economy was a dampener. The government coffers were not equal to the demands, particularly for steel and for the Hall of Nations. And this is where Mahendra Raj, who just set up practice in Delhi, reached one of his finest moments when he took up the challenge, and what he achieved was as remarkable for its inspired economy as for its design. The engineer's physics can make him value light and wind currents conjoined with empty spaces. He can use water bodies with its mobile quality as counterpoints to the stillness of concrete. The Hall of Nations, a pyramid rising not out of sand, but out of the stretch of water, not ominous and heavy, but light and soaring, is now a memory for people like us. A fleeting moment, a mirage echoing with the sounds of brisk feet, happy laughter and conversations, shadows of people lagging bagfuls of books after the book fair. This opens a major issue, and this is the second point I want to make, that is not moving away from just that of Delhi's buildings, that of heritage, a word much used and even overused, and not very thoughtfully very often. Today's architecture and engineering feats become the heritage of tomorrow. The Imperial Institution of the Archaeological Survey from 1904 named buildings and sites which had to be protected. Ironically, colonial architecture has taken a very long time to be added to this list, and many buildings have been demolished in the process. Mandi House, not a colonial building, but built before independence, built in the 1940s, was demolished, and it was a huge building. I don't know in how many of you remember it. There is not a single photograph of it available, to make room for Doordarshan Bhavan. As far as I know, this landmark event passed without comment. The name survives. When we did a kind of little survey of people going to the metro and asked them what Mandi House was, they said, Sabzi Mandi rahi hogi idhar. You know, so that's what happens. You don't know, you don't care to know, you can't find out. So the sense of the city disappears. The cycle of destruction and construction will only continue to accelerate as the land that is available shrinks. The charm of Delhi is that it has grown incrementally for centuries. A city does not grow by replacement. The second generation of independent India was not part of the historic city, if you like, but when we began to look at it, we noticed that this too had a sense of landscape, its focal points of beauty. When heritage walks became increasingly popular, modern Delhi was not seen as heritage. So, is it surprising that no one mourns the Indira Gandhi Center? No one thinks about the fact that the National Archives extension is rubble and that the National Museum may disappear any day. So that the whole of nation destruction was the first stone. There's going to be more. It is the indifference that is cause for concern. Anticipating this, by the way, because this might be forgotten, some 15 years ago, there was a group of architects who compiled a list of 62 post-independence buildings in Delhi which deserved heritage status. If they had succeeded, Mahendra Raj would have been given his due. I leave it to you to think of why the list was rejected by the Urban Art Commission and by the Heritage Conservation Committee. Peer group indifference in the case of post-1947 buildings. In the case of British buildings, a vague sense of anti-colonialism. Communal prejudice in the case of Sultanate and Mughal architecture is going to leave us with a tragically pruned and distorted sense of our architectural heritage. My third point is about the skill of engineering. Engineering can be seen not only as the spine of architecture, but it can be measured in as a skill, part of what the UNESCO defines as intangible heritage. The Encyclopedia Britannica has a definition which I think is a marvel of exactitude. Engineering means applying science, you must have read this, to convert resources of nature to the uses of mankind. The word engineer has a very old pedigree, derived from a Latin word engineere. It means to contrive, which actually translates in Hindi into jugaad, which we talk about with sort of slightly facetiously. What has been written and said about Mr. Mahendra Raj highlights him as a person with the qualities of an ideal engineer, not just a gifted one, with an innate humility, eagerness to learn, an understanding of materials, and working harmoniously with a team. The first comes out in comments by colleagues and others over and over again. The second, which recalls an old Arabic proverb, be determined to learn, and this is said in Arabia, be determined to learn even if you have to go to China to learn it. This is borne out by his decision to leave his work with Corbusier in 1955 and go to the USA because, as he said, there was so much more I needed to learn. And later to Italy to understand the works of Nervi. The third quality was the Indian in him. Laurie Baker once remarked that builders in Kerala had an amazingly nuanced understanding of materials and aggregates that they worked with. And Sanjay Prakash, in this book on Mahendra Raj, describes him as someone who has deeply understood the nature and behavior of his materials, the mark of a true poet. The fourth, again Sanjay Prakash, his work seems to proclaim the seldom remembered fact that buildings are created by teams and there need be no leaders and followers for the best results. That was the way Indian engineers worked. The Panchala, as they called it, were the 5 skills: carpenters, stone workers, goldsmiths, bricklayers, ironsmiths. When Gordon Sanderson in 1912, when they were talking of New Delhi, went out to identify Indian architects, he couldn't find any because they all worked in teams and nobody was given special credit as the head of the team. Srivatsan of Sept, in an article published 4 days ago in the Indian Express, has made a strong case for alliances between building professions. I don't know whether this affects your discussion on the bill, which you had just now. Anecdotes about the Panchala show them as confidently self-regarding, refusing to bow before anybody. Their skills and their philosophies were transmitted from father to son, and schools also taught a range of subjects. If you think about it, before, not just before this new education policy, whatever it is, comes in, but even before colonial rule, pathshalas and madrasas and people with skills taught a range of subjects. In a typical madrasa, the subjects were logic, mathematics, astronomy, chemistry, poetry, geography, and history. Now, these ridiculous walls between sciences and humanities, which we have created, did not exist. The term avadhani was bestowed on individuals who could do 5 things equally competently. A person could be a poet, a translator, a military commander, an architect, a garden designer. You have so many of these individuals. And if you just look beyond India, you have Leonardo da Vinci, whom, if you say his name, the first response that comes is the Mona Lisa. The Mona Lisa was the least of his achievements. I think what he really did, and if you look at the 2 fat volumes of his notebooks, you'll marvel at it, whether it was physiology, whether it was aeronautics, whether it was plants, there is no subject that he left untouched. He was constantly asking questions. I wonder whether he ever slept at night. So he is the person that you should look for, not just an engineer per se, but somebody who supplements that with other interests and passions, as we well know that Mr. Mahendra Raj did. Karl Marx wrote, I love the sentence, what distinguishes the worst architect from the best of bees, bees meaning the insect, is that the architecture raises a structure in imagination before he erects it in reality. This is what makes some of them poets and artists as much as scientists. And with what they achieve, is not to be relegated to that term I dislike intensely, infrastructure, which sounds like nothing on earth, sort of your visions of sewers badly, sort of treated badly, the people working in them treated badly. This whole concept of engineering should be elevated to the noble work it does, and it should be regarded as something one maintains with pride. And works of modern engineering, in turn, have inspired poets and painters. There is Hart Crane's poem to Brooklyn Bridge in New York, where he says, we have seen night lifted in thine arms when the bridge goes upwards. Then you have paintings. Turner painted Brunel's Bridge across the Thames, and he called it rain, steam, and speed. Rain was natural, steam and speed came in the 19th century. So if you just give me a couple of minutes more, just going into the past, the history, the word engineer, not engineer, but engine-er, was first used in the 14th century for those who built military siege engines, just as the computer has had its origins in the Second World War. With the addition of the adjective civil, it was applied to those who built aqueducts, cathedrals, metal bridges. But particularly for India, it was the spread of imperialism that really brought Western engineers into their own. Coming from the tiny country of Britain, the engineers were excited and challenged by the scale of India. Colonizing was worth the expenditure on engineers only when you followed them after the war, where they had been used, by introducing modern technology to build trunk roads and massive bridges. Iron replaced wood and stone. Britain and India, it is important to know, moved in parallel tracks. It's not as though Britain learned and then taught India. The first College of Engineering in Britain was in Glasgow in 1840. That in Roorkee followed 7 years later, only 7 years later, and many British engineers, in fact, were trained in Roorkee. Building India, the concept, became a continuous project. Kotley in North India, cotton in South India, those who transformed Punjab into a prosperous western half, enlarged the canals of Mughal India into big networks. These were the real rulers of India, not the viceroys whom we read about. Vishweshwaraya was a product of Indian tradition and Western education. What monuments British railway stations were, bordering on creative art and the Victoria terminus. Even now, I must confess, a thrill goes through me when the train to Kolkata thunders across the bridge on Derry-on-Soane. Even intoning the words, Great Indian Peninsular Railway, is inspiring. You might have noticed that there has been, in public discussions, frequent demands to rewrite Indian history. I'm with it, but though maybe what I visualize is not what is being suggested. I think it would be important to look for continuities and not breaks in our history. We need to end the patronizing attitude to the vast stretch of time before the 17th century, calling it pre-modern. Children with the alertness and instinct to become good engineers and the dreaminess to become artists need to know how people's lives changed, how gopurams and minars were built, canals and bawlis, ingenious bridges, the countless span of the Bada Imambara in Lucknow, and the ingenuity of suspension bridges, not the name of the ruler. I mean, in the old days, you have inscriptions, even in the two secretariats, listing all the engineers who worked on the building. Nowadays, you have a statement that some VIP or the other, with his Kar Kamal, what is it, inaugurated or whatever the bridge, you know. We are losing all our sort of the reality and have sort of substituting this for it. The legendary Sthapati of great brilliance in North India was a man called Vishwakarma. In the South, there was Maya. Their manuals are available, like that of Vitruvius, but they have been, these two people have been reduced to gods, and you have Vishwakarma Puja. It's fine, but you know, once you've given them divinity, then we cease to admire them as human beings. The Vastu Shastras have been written in many Indian languages, particularly in Odia, but they have not been translated, and some have been dumbed into mumbo jumbo. History has been written the linear way and does not clarify the zigzag of building technology transmitted from Egypt, perhaps China, perhaps Babylon, to Greece and Rome, then east to the Arab worlds and Iran, with offshoots to India, from where sciences found their way to the West. In some cases, there were breaks. For instance, we still do not know how Imhotep constructed the step pyramid of Saqqara in Egypt over 4 millennia ago. From the 3rd century BC to the 5th CE, Greece and Rome created a vocabulary of building, the Greek marked with fine detail in architecture and sculpture, the Roman by grand works of engineering, bridges, aqueducts, civic sculpture, fora, and so on. The knowledge of Roman concrete, however, disappeared with their empire and was replaced by weaker substitutes, exactly what happened in India with the disappearance of burnt bricks after the Indus Valley civilization. From the second millennium CE, that is from about the 11th century, a new wave of building and stone and brick spread through South Asia, West Asia, and the countries bordering on the Mediterranean. They're all at the same time. Because skills traveled great distances and there was no sense of intellectual property rights, it is difficult to disentangle the process of transmission. The Roman Empire broke up in the 5th century, but all over the world, the practitioners and the practice of buildings are still described in Latin terms. These terms link India via the British with the public works department of an extremely early civilization. The instinctive aptitude, the aptitude for engineering or contriving comes from an equally early building tradition in the Indian peninsula. The British engineers who in the mid-19th century repaired the Grand Trunk Road, which Sher Shah built on the shadow of the Uttarapath of the Mauryas, must have had their own memory bank. They must have described, in fact, it was somebody was quoted as saying that the PWD in India was second only to that of the Roman Empire. So if you ask the British what they were proud of, it was the PWD. Thus does engineering forge bridges, literally and otherwise, between peoples and times. And what a future this profession has, provided it learns something of the qualities, provided everyone in it learns something of the qualities that were embodied in Mahendra Raj: humility, delight in his work, an endless thirst to learn, and total integrity. In the wake of the cynical tragedy of Morbi Bridge, we so badly need a role model like him. Thank you.
Thank you, Dr. Gupta. Next, I would like to invite Ms. Shiny Varghese. Ms. Shiny Varghese is a senior editor at the Indian Express. In her 10 years with the newspaper, she has been following design and architecture in the country. She has helped in editing books and journals on design and architecture for practices and organizations, lending her voice to urban issues. Shiny Varghese.
Good afternoon. Well, good evening, actually. Thank you so much for this privilege, and it's been such an honor to be here. But more importantly, it's been a beautiful morning, and up until now, till listening to Narayani ma'am speak, it's been really wonderful to listen to stories that people had to share, colleagues and peers had to share about Mr. Mahendra Raj, and it's really such a privilege to stand here and an honor really to stand here and share my thoughts about him. So thank you to Rohit and thank you to Vandhini for this privilege, for the organizers. We all know about how meticulous, how strict, how warm and full of zest Mr. Raj was. And so I won't take my conversation there, but I'd like to title my talk as The Poetry of Mahendra Raj, because I believe he brought so much of beauty into everyday materials that I have always been in awe of, in terms of how his buildings soar and they float and they stand and they twist and they turn. And he did all that with such precision and such poetry. So I've been really, to say it very mildly, a big fan. And I work with a newspaper. And quite often the writing that we do gives us what we call a byline, which tells the world who the author of the story is. However, there is someone behind that copy who has possibly shaped it, given it coherence, added more grace to words, and often even pronounced my thoughts better. That alchemy is what finally makes a copy shine. And the same eloquence that a structure is given through the hands of an able engineer. And yet the role of an engineer, as does an editor, is seldom acknowledged. A French writer, Hélène Cixous, speaks about 3 roots to creativity. And these include the school of roots, spelled R-O-O-T-S, roots, the school of dreams, and the school of death. And how in the going back to the roots, the power of the imagination and the ability to move ahead is what gives us creative momentum. When I look back at the work of Mr. Raj and his life, and I see how he has adopted each of these paths in many of his projects. Just for instance, the way in which he returned to the US, returned from the US to work in India to find elements that anchored his design as an Indian. He also promoted a new way of thinking, and anticipation was imperative for him. There was no other way. You had to just move ahead. Satyajit Ray, in his writings on music, says that the structure of Indian music is decorative. It's not dramatic. It builds up slowly and becomes intricate and ornamental through its combination of notes. I know I'm paraphrasing, but that's pretty much how I've seen Mr. Raj's buildings, and the way that the Delhi NDMC building, for instance, where the sheer walls and the central corridor embraces the 2 wings. The way that in the Ahmedabad Municipal Stadium, where the folded plate cantilevered roof seems to kind of get onto some creative concrete crescendo. I remember the first time that I went to the Hall of Nations, where when I had just come to Delhi about 2 decades ago, nestled between the pink flowers of the silk tree and the orange red of the gulmohar, I never understood how that building could sit so lightly on the ground until I really began studying architecture and design. To a common eye, much of this is really lost. But the way it was demolished in April 2017, amidst all that rubble, I still found those joineries intact, where those 9 or 11 members met at a joint. And the world seemed to have moved on that day, but it didn't matter to them. But something else had happened. Possibly for the first time, we saw how aspiration of the collective had made way for the ambition of a single individual. As Rushdie says in Imaginary Homelands, it may be argued that the past is a country from which we have emigrated, that this loss is part of our common humanity. Mr. Raj, through his 6-decade career, has seen much, of course, and I'm sure towards the end he made his peace with everything that was happening. In an interview with him many years ago, he had mentioned that we are all idealists when we started out, and we still are. And that is something that I always found so completely refreshing about meeting him. And I met him for the first time, probably, like Narani ma'am says, somewhere in 2016. But it was always the pleasure of knowing that here was a person who had such a zest for life, a joy for what he did. And he had this incredible ability to look beyond the present and give that larger vision of life, which made him absorb the many failings of people and perhaps his own. To quote Rushdie again, we are partial beings, edifices built out of scraps, dogmas, childhood injuries, newspaper articles, chants, remarks, old songs, small victories, people hated, people loved. Perhaps it is because our sense of things and the world around us is constructed from such inadequate materials that we defend it so fiercely, even to death. We are often not the same people ever. We are different when we are in Delhi. We are different when we are in Goa, hugely different when we are in Dubai or Amsterdam. And each time we shapeshift. Then what is it then about our cities that make us live in multiple places as multiple people? And if we are such inconsistent beings, then what is it that is so constant in our lives? What are these safe havens we create for ourselves amidst the chaos of ruin and destruction? I think many of Mr. Raj's buildings allowed us that kind of safe space where we could tell each other stories, be it in the Crafts Museum or in Sri Ram Center, where one can sing and dance, be Hamlet and a Sutradhar. In fact, in one of my conversations with one of the theater actors at Sri Ram Center, he said he never needed a mic when he had to deliver his lines in an auditorium. It was just that it had the right depth, and he could kind of prop up multiple dimensional sets onto the stage, and there was enough space for the actors to still move about. The building itself lent to such inspiration that even pre-events were often held in the lobby before the actual play began. And what the actor said is that you can imagine many different worlds in that space. At a time when in one corner of our country, we are building beautiful tunnels with bamboo, in another, we can't handle centuries-old suspension bridges. Our river Ganga is both mother and is still desecrated and polluted. And we live in these contradictions as a country and as a society. And while most of us are uncomfortable with this kind of dichotomy, I think the poets among us dwell with that idea much better. So when Buckminster Fuller complained about the primitive ways in which this world's first in situ concrete structure, space frame structure was being built, Mr. Raj had somehow made his peace and had known that, it will still continue. The mixing of concrete is still happening. There are balis for scaffolding, human ladders. He was able to go back to the primeval and bring back something from there that is new. And the way that perhaps the first food gatherers realized that building round mud houses instead of square ones actually kept the house standing even in an earthquake. At a time when modern architecture has stripped our cities of its uniqueness and given them just uniforms to wear, Mr. Raj's buildings have stood apart in the way that they've been iconic and given to India many firsts. I think without him, Indian architecture wouldn't have had the global face it has today. I see him as a poet in his ability to invent a new vocabulary, having understood the rule book enough to defy it, the way he understood his structures and materials and elements, and we see that in so many of his buildings. When Rohit and Vandini curated his retrospective few years ago, it was phenomenal to see how poetic his drawings were. They were works of art in themselves, in their precision, in their form and balance and beauty. They say that some works of art stand outside of time, and the genius of Mr. Raj's buildings are like that. The question that I'm sure he often asked himself was, how can we be worthy of what our ancestors have done? And his life was an answer to that, in his perseverance, in his striving always to find solutions when people saw obstacles, in his pursuit of beauty. I'd like to close with what C.V. Raman had said in his lecture on Why the Sky is Blue, which challenges us to question. And in asking why we will find those answers, he says the clue lies in the inherent powers we have of observation and thinking. And these, I believe, were Mr. Raj's superpowers, his ability to think and observe and never give up. Thank you so much.
Thank you, Ms. Varghese. Next, I would like to invite Professor K.T. Ravindran. Professor K.T. Ravindran retired head as Urban Design School of Planning and Architecture, New Delhi. Founder of the Institute of Urban Designers, Ravindran has been on several important advisory policy-making positions in the country. He was the first chairman of the Urban Art Commission of Delhi and been a member of UN Master Plan Renovation Committee, vice chairman of EIA Committee for the Government of India. Professor Ravindran was the Dean of Rick's School of Built Environment. He has been associated with INTAC from inception to currently on the Governing Council. Professor Ravindran.
Thank you, sir. Good afternoon, everyone. And thank you, Rohit and Mandini, the onset to have invited me to speak here because I'm really the odd man out. I don't really fit into the kind of engineering tradition through which Mahendra Raj came. But I have a 4-decade-long active association with him, going back to the 80s till now. And I just want to describe to you 7 of those occasions on which I have interacted with him on a professional capacity. Not as an architect and engineer, but as people who were engaged in inquiring into issues which affect society in different ways. So in other words, what I want to bring out through these 7 encounters, which I'll describe to you, is the fact that Mahendra Raj was not just a damn good engineer. He was a lot more than that. He was a man who was able to, thank you. He was a man who was able to transgress the boundaries of many disciplines and take on the role of a kind of arbitrator in a number of different situations. And to my mind, it is that ability to transgress disciplines, transgress situations, which made him what he was. That is the kind of curiosity which he had even as a 90-year-old was equivalent to that of a child. In other words, he was a man who was eternally curious and therefore able to ask the right questions and enter the right frequency within any problem so that he can provide a solution to that problem. So that was a very special quality which he had. I'll very quickly go through the 7 encounters which I've had with him professionally. The first one was not with Mr. Mahendra Raj as a person. It was back in 1972, prior to the inauguration of the Pragati Maidan, that is for which the whole campus was built. When I had just joined SPA as a student of urban design in 1972, and we were given an exercise in the class to go and study the Pragati Maidan campus and to critically comment on the issues of design in the Pragati Maidan. And that's the first time. That time, for instance, the Hall of Nations was under construction. It was in its finishing stages because it's in the initial months of 72. And it was in November 14th, I think, if I remember correctly, that it was inaugurated. But before the inaugural, they were like quickly trying to clean up the place and take off the shutterings and remove the swans, etc. I probably have some black and white pictures from that occasion as well. Even now, they might be lying around with me. But that is the first time I encountered that kind of a robust engineering solution, which one doesn't run into anywhere. Looking at an intersection of different elements coming together, and becoming just a kind of almost like a magical kind of entity where you cannot figure out which member is in tension and which member is in compression, and nor can you figure out which node or which intersection of these elements are actually forming the essence of the structure. It was an extremely puzzling thing for me as a student. I was a student of urban design, but I had already done 4 years of practice before I came to join urban design. So I was quite bewildered at that structure. And I realized that the man who could do something like this must have been a very special man. So that was back in 1972. But my real personal encounter was with him in 1989, when there was a court case that was going on, very famous court case going on between a university and an architect. And after 4.5 years of fighting the court case, it moved into an arbitrator's court. And the arbitrator appointed me as an advisor to him. He was a retired Supreme Court judge. And I had the privilege of sitting with the judge on the dais and explaining to the judge what each of these technical terms meant, which he did not understand. What is working drawing, what is services, what is infrastructure. He did not understand those issues. It was my job to explain that to him, what it means. And a number of hearings were made in Delhi. It was like a regular court. There would be 2 lawyers and a number of people who come as witness, and they get to the witness box and they answer questions from the lawyers and so on. And it's like a regular procedure of a court. And in the course of those interviews, we had stalwarts of the profession like Mr. Kanvinde, Reval, of course, friendly involved in the whole case itself, and Mr. Mahendraj was in the witness stand. Now, before Mr. Mahendraj came onto the witness stand, there were quite a lot of other engineers. He was not responsible for the design of that university. Mahendraj wasn't. But he was brought in to bring in legitimacy of the architect, to show how legitimate the architect's work was. And it was a very toxic process in which each witness was, kind of, first the lawyer would go and break his confidence in himself. He'll make him completely be shivering in his pants. And most of them are like, engineers who are normally working on the site and so on. They're not the kind of people who can stand up to a eloquent lawyer and answer. So they would destroy their confidence. Then they'll ask some pointed technical questions when the poor engineer will fumble in his answer. And the lawyer will give a long, sarcastic pause and will turn to the judge and say, that's all, Your Honor. In other words, this man, whatever this man says, cannot be relied upon because he does not know what he's talking about. After that came Mr. Mahendraj on the witness box, and suddenly the whole environment in the courtroom changed. Soon as he stood up and he started speaking about his craft and his association with the architect for a prolonged period of time, the lawyers themselves took a back foot. That aggressive stance was not there anymore. There was almost, he had taken over the whole environment. Mahendraj, by his persona, had taken over the environment. And there was an atmosphere of admiration. And all the aggression in the lawyers just went down. And no one asked him any single extra question from what he said. And Mahendraj just walked out normally and sat in his seat. This was my second encounter because I was sitting on the dais with the judge and I had to explain to the judge all the technical terms, as I said before. And this Mahendraj's persona and the kind of confidence that he exudes by virtue of his sheer groundedness in his own subject was something which disarmed everyone in the hall. Yeah? And to a large extent, it made a great impression on the judge as well. This is a very interesting case, but I won't go into more details with. My next encounter with him was in the 1990s when I was actively working with INTAC on the restoration of the Rashtrapati Niwas in Shimla. It's a building that goes back to 1880s, 1888 actually it was inaugurated. It was the first building to which Electricity was brought in on a regular basis, and building had displayed some levels of distress after almost 100 years of its existence. So there were places where there were large cracks in the building and so on. And it was with the CPWD who was unable to either understand the causes of the cracks or the methodology to stitch those cracks in place. So under Intact's banner, I was working on that project, and we searched far and wide to find an engineer who can work on a traditional structure. That is, on a traditional structure means a simple masonry structure, just that it was big and it also had large spans. And finally, Mr. Mahendra Raj was adventurous enough to say that, okay, I'll take that on. And I traveled with him and his wife to Shimla, which was actually my first bonding with his family. And his wife was also a very interesting woman, very learned person. And I had been a big fan of her. His wife's sister, Dr. Ratna Naidu, who was in Hyderabad at that time. And Mahendra Raj was the only one could find who's willing to go and learn about a masonry structure and its failure over a period of time. So that's where I had long discussions with him, personal and professional, in the car, and had got to know him very close. I'll have to move a little faster. Much later in my next encounter with Mahendra Raj was in SPA, that's School of Planning and Architecture, where at that time in 2006 or 2007, I had become the Dean of SPA. And Mr. Mahendra Raj was invited by our academic council to rework the PhD program for SPA. Okay? It's a bit of a stretch if you think about it, because Mahendra Raj is a man who knows his steel, he knows his concrete, he knows his craft so well. But here he was being invited by SPA to rework the PhD program. That demonstrated his ability. And I worked very closely with him at that time because I was the dean of the school and the PhD program is under the dean. Yeah, so it was my personal responsibility to make sure that what Mr. Mahendra Raj proposes is actually then taken back to the academic council and they approve it and we put it into practice. I suspect that it's the same framework that Mr. Mahendra Raj proposed, which they are still following, and where Vandini is one of the people who are working through that system right now, doing her PhD. So going back to 15 years, there was the case of Mahendra Raj, who did not have a PhD, and me, who does not have a PhD as the dean, working out a new framework for the PhD program in SPA. And one could see that he had the capacity to enter a subject, go down to its very basic bare minimum, understand its structure, destructure the whole issue, and then reconstruct it to say something new. That was a tremendous ability that he displayed at that time. This is quite apart from what a good structural engineer skill is. It's much, I don't know whether it's much more or much less, or whether it's the same skill. It's one of these things, but the man had the capacity to enter into a subject, completely deconstruct it and reconstruct it, giving it a new meaning. And I had the privilege of then representing his report to the academic council, getting their approval, and then coming back to put it in implementation. So this was my next encounter with him. And my fifth encounter was in the Delhi Urban Art Commission, where I was privileged to be a member for 5 years, where he had come on many occasions as consultant, not as one who's bringing a project for approval, but on invitation of the DUAC, experts come in to comment on issues. And he came in on many occasions as the consultant. But when much later during 2009 and 2012, I was the chairman of the commission. Earlier, I was only a member. When I was the chairman, it was an occasion in which the DDA had said that they will permit extensions to existing buildings. They'll increase the FAR of buildings which are already existing. For instance, all these flats which are built in different parts of Delhi, including that of Dwarka, etc., would be permitted to have more floors. They'll be permitted to add more rooms to existing multi-story buildings and add even more balconies if they wanted to. So this was a kind of a blanket, kind of concession made to the building industry by DDA. And in the commission, we realized that this is going to be something which can be quite risky as far as the structural integrity of the buildings are concerned. So Mahendra Raj was invited to come and analyze the implications of this kind of additions on earthquakes, because earthquake was a hot topic at that time, and how the remedial measures for this has to be found. Because whatever recommendations we make has to be a substantive recommendation. It can't be just flippant comments based on our opinion. So we had Mr. Mahendra Raj sit with us, decipher the whole problem of this additionality to structures and their susceptibility to earthquakes, and how to remedy them if it needs to be done, or take back the law. There was only 2 options possible. And that was the other occasion where I had the good luck and opportunity to interact with him closely on a professional basis. Once again, not as a structural designer and an architect. I never grew to that stature to have him as my structural consultant. I always had to go to his chelas to get my work done. But here he was able to enter the subject once again, penetrate the subject, analyze its parts, and put it together to give it a new lease of life and meaning. This, I think, was a very special ability which Mr. Mahendra Raj had, which I have not seen in too many people. Perhaps it is quintessential to anyone who thinks in the integral way that he thought about things. For instance, how he crossed the boundaries of architecture and engineering, that traditionally fighting like cats and dogs, architects and engineers. And here you have a man who can transgress both these with equal ease and make his structure the architecture and make the architecture into his structure. That was a special ability to integrate conflicting things in a condition and bring it to an integral position. That's something which a very special power that he had. I had a few more encounters before I stop. The next interesting episode of my interaction with Mahendra Raj, once again in a professional capacity, but not as a structural engineer and architect, but as part of a committee to inquire into contract management for this very building, India International Center. India International Center was planning some additions. You have seen the additions which are made at the other end of the Lodi Garden end of Swan. And Mahendra Raj was invited to be scrutinizing the contract document. Not simply because there were controversies about contract document, also because there was a controversy between DRDO, which were the advisors to IIC, and the architect. DRDO wanted to add more rooms on top of the buildings, and the architect said, no way I'll do anything to these buildings. These are made by Stein. My respect for him is far beyond making an additional name for myself by adding a set of floors to them. So he put his foot down, and then Mr. Doshi was invited to come from Ahmedabad. Doshi came and stayed here for a few days in the IIC, and he also advised through Mahendra Raj by getting into the nuts and bolts of the issues. And there we also had the opportunity, I had the opportunity to travel with Mahendra Raj to various sites where the potential contractor had already delivered fresh works, where unplastered concrete, for instance, or places where shuttering is just being removed, so that you can really see the condition of concreting before it's like kind of repaired, or the contractors quickly slap on some cement and prettify the thing and give it some brushwork on with concrete slurry and so on. Before any such thing was done, we had the opportunity to travel and look at some of these works. So this was a very interesting occasion for me, because a contract management needs to have the capacity. Manager has to have the capacity to understand the quantitative contents of the quotation process, as well as the qualitative content of the delivery that this man is capable of doing. And working with him on that was a great learning curve for me, where with Mahendra Raj, this was, I think, around 2010 or so. I don't recall exactly the dates, but it's in the latter part of 2020s that we had this opportunity to go together. Then altogether, my experience with Mr. Mahendra Raj stretched from the 80s to 2020. It's almost a 40-year span, even though my first encounter with his concrete was in 50 years back, that's in 72. But this 20 years, this 40 years of interaction with him actually also culminates in a number of places where I had the good fortune to share the dais with him. That is, we were on the same program. Say, for instance, there was some event happening in the Habitat Center on the future of cities. And Mr. Mahendra Raj is the most important speaker on the future of cities. It's not about concrete, it's not about steel. It's about cities which consists of concrete, steel, and 100 things more, plus people. So he had the capacity to enter a subject which was not necessarily central to his training, but it was integral to his understanding of what is built environment. I think that I'm just giving you one example, but my first encounter sitting with him was in the Sushant School's convocation in its early days in the 80s, where I also happened to have been part of the advisory group on the academic board. And Mr. Stein and Mr. Mahendra Raj were both speakers on the same dais. I am a small fry. I was sitting in the corner, and I was learning from every word that these two guys would utter. Okay, I'm not saying that putting myself sitting on the dais with him. I'm not trying to state that. I'm trying to say how my learning from him actually stretched across a whole range of professional activities. These are only professional activities. I'm not talking about the number of times I've sat with him in a discussion on poetry. I'm not talking about the number of times I've sat with him on discussions on art, or on philosophy, or on literature, or anything else that is not steel and concrete. He was one of the few structural engineers, you can say, or engineers of that seniority and capacity and reputation to take interest in all these things. And he would be a regular at the IIC on all these occasions, whenever there are many interesting things happening about culture. So, and I had the good fortune of very often accompanying him to the car, even when he was infirm and advanced in his age. I had the good fortune of, kind of him holding on to my shoulder and walking to the car. And number of such meetings that we have had, I lose count of the number of times that I've been in meetings with him. Sometimes I was a discussant on his talk. When he's talking about a structural engineering issue, I have been asked to be the discussant with him. And I was very privileged to know through some of the letters which I still have, which I was going through, that some certain embassy had written to me saying that we are requesting you to be the discussant on the suggestion of Mr. Mahendra Raj. In other words, it was a real privilege to have had that kind of, enjoyed that kind of confidence of this great man whom I admire so much in me. And it is a big learning thing for me, because every time I go into a new interaction forum with Mahendra Raj, it was altogether new things that you learn from him. Yeah? And besides this, I also had a very warm personal relationship with him. And I consider that great privilege. And I consider this occasion to be a great privilege to be speaking to you about my encounters with him. And thank you one and all. I hope, Tanuja, you will have a discussion now, or do we? Yeah. Okay.
I could show the vote of thanks to you that you explained this man and your personality. We are privileged. We are recognized right now, but thank you very much.
Thank you, Arun. Thank you. Thank you. Walk across there.
Thank you, Thank you, Professor Ravindran. May I now invite all our panelists on stage for the discussion moderated by Ms. Tanuja Kawinde. Ms. Tanuja Kawinde is a partner at the studio practice of Kawinde Rai and Chaudhary, based in New Delhi. Through her professional journey, she has had the privilege of being mentored by some of the modern masters of the country like Padalkar, Joseph Allenstein, Murad Chaudhary, and Achyut Kawinde. Ms. Tanuja has been actively involved in academics and has been a visiting faculty at School of Planning and Architecture, New Delhi, for over 2 decades. Yes.
This is a conspiracy of bringing sarees.
Thank you so much, Studio Vanro, for this. Really, really very privileged to, honestly, I told Rohit, you don't need a moderator for this session because the speakers are complete in themselves and the manner in which they're kind of taking across various topics and unfolding what Raj was is complete in itself. So this discussion is really very, very superfluous. Yet, thank you, Vishalakshi. Yeah. So we had a little chat, just getting to kind of know what each one was going to talk about, etc. So very nicely, I think the speakers, as you've all heard, wrapped what Mahendra Raj was. And I must say, I mean, like a wonderful visionary designer and educator, a warm and compassionate human being, a just and able administrator, a music connoisseur, a marathon runner, any number of adjectives which can't really sum up what he was. and a model for Brill Cream, which Katie is very fond of reminding all of us. But the new name, I think I really love what Narayani mentioned, Avadani. I think if that can sum him up, it really, I don't know. Yeah. So it was really fantastic. I had many years of working, having heard of him through the firm I was working as a young architect, and subsequently interactions with him on projects that we designed. So I think we've all heard through the morning his engagement with the structure. The structure was absolutely, so he always wanted to understand not what you wanted out of him. Obviously, we're going for structures, but he wanted to know what the brief was, what the client's, desire was, what you wanted to do. He would engage with it so completely and finally come up with a solution. It may be very different to what you went to him with. So in a lot of cases, as you've seen right from the beginning, from the 60s, there have been many instances when the spatial aesthetics of the structure changed completely. When architects went to him and then what the end product was really something else. So really, when you look at it, the integrity of the structure he conceived for each project was sheer poetry, maybe a subconscious resonance of the music, both Western and Indian, that he was so passionate about. I mean, it really was like a person who was complete. He would have this music going, and that's the poetry that you really see in all his structures. So it was really difficult to kind of separate him from that. I'm just going to quickly talk about just 2-3 things which made a huge difference. His friendship with structure was so intense that irrespective of the scale of the project, he always contributed something unique to the project itself. He took his work very seriously and was engaged completely. And with an understanding, he would always alter the project. A delicate balance between being firm in his professional decision while being gentle in his interpersonal dealings was always a very remarkable, character of Raj. Towards February, when the MoMA opened the exhibition, and a large part of it, a number of buildings, I think they showcased architecture of independence, and many architects' work was showcased, but the common thread through all of that was Raj. So I had written a message to him, sending a cutting of it, and he said, "Thank you for another report which covers the exhibition. I'm very happy that this exhibition in the Museum of Modern Art has made the work done in various countries covered by the exhibition known to the entire world. I hope more exhibitions like this one are held all over the world. As we all know, the work done in these countries in the period covered by the exhibition is significant." He was actually very, very conscious of the significance of the build, the beauty of the form, aware of the heritage he was creating. So, and this is as late as February this year. So he had always the lady in the office, Nirmala, who would type out and send out. So with his failing eyesight, he would use a magnifying lens. We went to meet him. He actually wanted to know what the issue was. He would look at it with the lens and absorb the issue and come up with a solution. So these were the kind of, and Bharat Sukagakai, I must kind of also share this. This was in 2017, I think. We had this project. So went to him because it was a very tight urban site, and we didn't want columns in between. So said, this is a congregation space, so maybe we need to kind of. Then he came back and he said, "Look, do you think you'd like to give a slight curve to the beam?" because it's a prayer hall. So, I mean, like, that was the kind of involvement that he had. And then during the excavation and construction, there were some cracks which appeared on a retaining wall. Clients got panicky, and there were no, typically like all our sites, no method of even getting safely down to the basement level. But Mahendra Raj came with me, went down, saw the place, and then I actually have a recording of his discussion with the clients and how he convinced. The building got completed, by which time he had started losing eyesight. He wasn't really clear. The vision had got hazy, yet he wanted to come in and experience the building.
Tanuja.
Yes.
Tanuja, can you keep your mic closer, please?
Yes.
It's not at all audible.
Sorry. I'm so sorry.
Yeah, fine.
So he came in, and so I requested the clients and I said, we would like to come, all the consultants, we would like to come. And Radhika here, who was also on the project. So he came, walked through the entire building and experienced it. So, the vision wasn't really directly there, but he could feel the space. And he experienced, so I think earlier in the day, there was a talk about how it is not about making just drawings, but it's also about experiencing the spatial quality. So it was really that. So he probably relied on the sounds and what the space kind of, the feeling. So there is an intangible that he also was very, very, very integral part of. So these are like a few things that I thought I must mention about a person who was very special and who kind of, talking about what each of you had to say. You really, Narayani, you really put things in great perspective. But in the present context, how do we keep these memories alive when there is so much pressure on the build? Land is of great value. So the first thing that's getting axed is all the buildings which are of a particular period. How do we make this actually preserved? How do we make this history alive? How do we? So also, for the two of you, I have this question. I'm actually a little taken aback that you only met him around 2016, though you are primarily from Delhi and one had never an occasion to meet. So that really shows that as designers and engineers, we're really a very small fraction of the society, and the society hardly knows you. So and we are actually creating the build. So how does it?
I don't know that the suggestions I'm making are particularly, I think they're doable. One is that this is really from what I said already. Buildings should be identified by the creators. There should be some kind of thing, placard, whatever. I was really shocked when this happened at Teen Murti, because I organized a talk called Knowing the Architect of this place. Nobody knew what I was talking about. So that is important. The other is that it should be integrated into education. So much for the new education policy, that you should learn about who built and what is special about the architecture or the engineering, not just in terms of height and weight, which they always give, but making it really exciting for children. They do this so well in other countries, so we can easily do it. And the third is to have a museum of architecture. We have no place where people can go and see models of buildings which matter. I'm shocked at this. You have of art, you have of, well, that's about it, really. Don't have much. Yeah. Okay. So, sorry. Yeah. So those are the three signposts, and a museum, and integrating it into education, not in architecture schools, but generally. Thank you.
I'd like to take this further to you, Shaini. Basically, when Hall of Nations happened, it's actually 10 years ago when Mahendra Raj gave his retrospect, courtesy when I was a chairman of an organization. He actually stood on stage at this very premises in the other hall for 2.5 hours, and he took us through his entire oeuvre of work with so much enthusiasm, and he knew every little bit about it. And so one really kind of, at that point, I did mention about the Hall of Nations, and I said, all of us as fraternity need to do something and protect it, etc. So that's when the first time, 2.5 hours, and he took us through his entire oeuvre of work with so much enthusiasm, and he knew every little bit about it. And so one really kind of, at that point, I did mention about the Hall of Nations, and I said, Hello. As fraternity need to do something and protect it, etc. So that's when the first time, 2.5 hours, and he took us through his entire oeuvre of work. Can we just, with so much enthusiasm, and he knew every. Yeah. So, and that was about 10 years ago. And then it took us that many more years finally when it actually came down. So you realize that except for a group in the north, the rest of the country, it didn't matter at all. And this is where I would like to ask you, after all, media, journalism, writing, these are the really ways of reaching out to the public. Do you know, how do you think we can actually make this a little more, reachable? How can we have an outreach to make the common man aware of?
Thank you. It's when the Hall of Nations came down, what came as a surprise to me is that within, forget South India, within North India, people were divided about what that building should actually be, or how that building, should it be or should it not be? It was this a question that kind of divided the fraternity itself. And I said, if it was a journalist and there was something that had happened which called everyone to stand up together, if it was a medical fraternity that that even one doctor was slapped or something, everybody would be out there on the street. If it was journalists in some way that somebody was assaulted or somebody was in jail, then everybody would be out there. But I was surprised to see that the architects themselves were very divided, very kind of, sitting on the fence kind of a situation. So that itself to me came as a very big revelation, if I may say so. So how much can media do? We, of course, there were articles that went around and everything, but I think unless the architects itself as a community of people who come out to say that, okay, this can happen at the street level. The reason that most of us don't know who architects are, if you're not in the profession, you really have no clue who an architect is or what an architect does, who an engineer is and what they do. That's also because there is no visibility on your street. And I don't mean putting up a signboard. What I'd say is that, if people can get involved, I had recently done a story on the Vasant Udyan that everybody really here should go and see, because it was a collective civic, what shall I say, initiative that happened, where people, common people, RWAs got together to actually revamp a park, a local park. The reason they could do that is because they started that in their own colony, where they, ensured that they get water into their colony to water their plants, they do their composting, they do that. So if architects, if engineers can start working at the street level, I think that itself would make a big difference to me knowing as a person who's not an architect or an engineer, knowing that, oh, there is this so-and-so person who's actually involved in some way, on my street. So that visibility itself makes a big difference to how we would react. The reason that that quite often it gets hidden now, as we can see, Delhi is going through a complete revamp. Every place there are cranes and there are mud heaps that you see. That's because it's actually very easy to bring in bulldozers, as we know. Now we've come to this bulldozer Raj, as people have already spoken about. So why is it happening? Why is it that unlike any other country in the world, we don't have people who are coming out and saying that this cannot happen? So of course, media can play a role, but unless people actually, media by themselves can only have an opinion. If you have to report a news, we need people to do that. So which means unless we have people on the street, I have nothing to report. I can, at my end, write a column in my newspaper and say, okay, this is what I feel and this is what it is. And that's it. 5 people will read it and it's gone. But when there's a visibility on the street, when there is some kind of action on the street, is when it becomes something that everybody can own. And I think that is where we need to move.
Because I always feel it's important for designers, architects to write a little column in the newspaper, because newspaper still has a great reach to the common public. And even if one is, so we do look forward to the articles that you write about the newer developments that happen, but somebody like you, there are very few, and Narayani's, sometimes when she writes in Times of India, it's always a pleasure to kind of go through, or maybe in the Hindu or Indian Express, whatever. But so what I'm coming to is essentially, I guess we need to then write. So in which case, then I suppose we also need to have a little bit in the curriculum, which integrates about writing, because we really don't have writing skills. As designers, I don't think the writing skills are kind of honed. So that's where I suppose we need to write. I wanted to just check with Dr. Visalakshi. You spoke about the many tenets that Mr. Mahendra Raj, kind of shared with the younger designers, etc. How are we actually bringing this passion into schools of engineering, where they teach, civil engineering, structure? Because here it was about one person who had a passion and he kind of, followed it through. But yes, that's just a last question. Yes. Yes.
Yeah, see, if you look into the academic curriculum or the academic structure of any college, see, the school or the college can teach a student a limited content, isn't it? Okay, it has to be the inquisitiveness in the person itself to learn beyond the 4 walls of the school or the college. Okay, whatever the tenets or the points which Mr. Mahendra Raj has been given to the younger budding engineers. Okay, we as a teacher usually insist on those points, usually. Okay, because for example, if you look into the third point, the third tenet which I've spoken about, which Mahendra Raj, Mr. Raj has insisted, is first do any design manually. Okay. If you can't do the design, don't expect the computer to do so, isn't it? So we teach in college, first we teach the manual design, and then we try to compare it with the software thing in order to refine it or do a confinement to this. So, but coming to the actual experience which engineer or the outside world gives, the academic environment or the college environment cannot provide. Okay, it's up to the individual person to be a sponge and absorb the things. Okay, the academic environment has limitations. It has to fulfill the academic courses, academic curriculum, so on and so forth. So it may not be able to provide the entire feel of what a young engineer has to perform in the outside environment. So that's the reason now in the new education policies, we do have the internships, which are compulsory, whether it's industry internships have become mandatory now. And it has also become mandatory for an engineer to go into an industry and perform a project over there, so that they can utilize whatever they have learned in these all years in the college. So now there's a gap between the academy and industry, but slowly or eventually, I think it will be closer.
Thank you. Thank you. We're running short of time, so I think.
Yeah.
IIC is going to close. I think request Bandini to say a vote of thanks from here quickly.
No, just we have to, unfortunately, we've even gone beyond our time at IIC, and they have another event at 6 o'clock. So we will conclude the session for today and hope for many more like this in the coming years. And I thank you, really deep gratitude for this on this special day from IS Shakti and SVR Foundation and MRC to all the participants who are online and who are here, and all of the panelists who have made this effort to really spend their time and have these engaged and thoughtful, insightful discussions, presentations, and sharing their journeys with us. Thank you so much. And there's tea outside in the veranda. Please, let's continue our conversation there.
Thank you. Thank you, Nandini. Thank you.
Which is Mr. Raj's favorite. So please.